Hello folks, as usual, Chris VK3AML with the regular Saturday night live stream. This is done almost as a tradition as a result of crossbands that were established by my predecessor with my call sign, the late Tony Sanderson, VK3 Alpha Mike Lima, and just today we were over at his widow's place celebrating a birthday celebration for the lady of the family, so we've had continued to keep very good friendships going there. It's been an interesting week. I've tried to get permission from people for tonight's live stream. Haven't succeeded, so we'll have to trust to luck, and if I get a copyright infringement, I'll simply delete it from the live stream and go to alternative material. But should be a fairly interesting night's session. Just checking on my live stream. As always, it's there. I always panic that I'll put this stuff up and one day the OBS streaming software won't connect with my internet for some strange reason, but so far so good. Well, it's just coming up to 9:30, and I'll hit the switch and then I'll call QST. Another way of saying CQ, I guess. 9:29. Quite a bit of material to get through tonight too, relating to software-defined radio, possibly the most important material that I'll have to show for any ham radio operator out of all of the material I've seen on this channel so far. Software-defined radio, I kid you not, now that I've seen it, can see what it can do. I think the days of hardware-based radios, superhet in particular, are very numbered. Okay, it's 9:30. Let's go on the air. Hello, QST. This is VK3 Alpha Mike Lima with the regular Saturday night live stream and simultaneous transmission on 147.475 megahertz in the Melbourne area. The live stream on YouTube that carries the video that goes with this audio you can find by dialing up VK3AML 25 June 2022. That's dial VK3AML 25 June 2022, or go to my YouTube channel, which is under the name Oz Radio Historian, AUSRADIOHISTORIAN, and those three syllables as one word. Oz Radio Historian, AUSRADIOHISTORIAN. Tonight, a series of lectures. The first one was originally delivered 5 years ago by Gerald Youngblood K5SDR. Why SDR? Because he's the president and CEO of Flex Radio in the United States, one of the foremost producers these days of software-defined transceivers of a very high order. I suppose between Flex Radio and Anand, they have the top of the ham radio market at the moment. And Jerry will be talking about the reasons that software-defined transceivers are steadily taking over the top end of ham radio and working their way down the price list as well. Following that, a subject that probably hits a bit close to the wind for some people, and that is over-the-horizon radar. How does it work? Where is it? Who uses it? And how does how do the antenna systems and all of the receiving systems work? Well, I've combined the best of what can be found on the internet from variously the Royal Aero Club of Western Australia, the Old Flyers Group, Defence Science Technology Group, Lockheed Martin Australia, and Chris Moyer, who's from ANSYS Government Initiatives in the United States, United States National Security, and he is a person who has devised software modelling programs for ionospheric propagation that allow over-the-horizon radar to work. And finally, I've found an article in the IEEE Proceedings for 1994 which describes basically the technical operation of the JINDALEE project, the 3 operational over-the-horizon radar stations operated by Australia. So, first of all, without any further ado, I'll thank somebody for a particular device that's come my way this week through Mick Maxwell, VK3AML, and I'll just show this. We can now go on 2 different cameras. You're seeing the wide view of the Radio Shack, which I haven't been able to see on live stream before. Seems to be working quite well, and thank you to Mick for arranging the camera for that. Just by chance, Mick happened to have the same camera that I use here, a Logitech C930E. So the 2 of them integrate beautifully to give coverage without any colour shifts or contrast shifts between the 2 cameras. Delighted with that, Mick. If you're watching, thank you very much. So with that being said, let's go to Gerald Youngblood K5SDR, President of and CEO of Flex Radio Systems, to talk about the advantages of software-defined transceivers. And this was recorded at the ARRL Confab in New England in 2017, 5 years ago. So whatever he says has now been improved upon. This is just a general view of the principles and the theory and the physics of software-defined transceivers, which I'm sure will be of interest to many people. It possibly is the biggest leap ahead we've had in transmitter technology since the development of single sideband. Over to Gerry Youngblood K5SDR.
I'd like to give you a very high-level overview of a lot of things today. I normally don't like to cover so many subjects, but so many things are happening in SDR, so I'm going to give you a broad brush across the whole spectrum rather than going very deep into any subject. And so I hope that you'll find that interesting. I'd like to start by saying that my beginnings in SDR, I'd like to give you just a quick overview of that. I'll talk about the topic of the software as the radio. In SDR, the S means the software is the radio. And I'd like to also say the network is the radio. Sun Microsystems talked about this a number of years ago, and it's becoming true in radio as well. And then I'd like to talk about what's new from Flex Radio, give you a brief overview of some of the things we're doing. So my beginnings were in 1999. I learned about software-defined radio as it was used in the military and commercial applications, but not in ham radio. And I became interested because I played with PSK31. I plugged into the sound card, and I was able to copy signals I could barely hear. And I said, that's pretty cool. And I remembered some theory from my college years. And I said, maybe I could build a radio using a sound card. And I hadn't done engineering since 1978. And this was 1999, and I had forgotten more than I'd ever learned. So I dug in as a hobby. And fortunately, we had the internet. I could get on the internet and study and read books and things like that. And so I had to build some hardware and some software, because a software-defined radio requires physical things to connect to the antenna. And so these were the first prototypes, starting from left to right, of what is I came to call a Quadrature sampling detector, which would do a single down conversion to a audio IF frequency, which the sound card could bring in up to 192 kilohertz of bandwidth. And so these cards allowed me to do that experimentation. And the one on the right actually implemented a transmitter. The one on the left was just the receiver. And then that became a 3-board set that you see down there that I call the SDR 1000. And that happened through 2002. Well, I had such a hard time, since I hadn't done engineering in a long time, digging all the math and so forth out, that I said, maybe I could make this a little easier for other people. So I wrote a series of articles for QEX. These are published on our website and available elsewhere. And just to try to make things easier, and it was called a software-defined radio for the masses. I wanted to call it SDR for dummies, but that had been taken, so unfortunately. And those articles came out through 2003. It was purely a hobby project. It was not a business at that time, just to see if I could do it. Around 2003, I decided, because I had written these articles, people had written me from all over the world and said, I'm interested in this. Can you tell me more about it? Can I build one? Can I have a kit? And I said, well, I'll build 10, and you'll have to tell me why you should get one of these 10. I got 50 orders when I sent out an email, and 500 in the first 9 months. I said, well, maybe there's a business here. I'm an entrepreneur. Maybe I'll start a business. So I just did that in 2003. So we're coming up on 15 years. When we started in 2003, in a room like this, if I ask how many people have heard of SDR, how many of you in 2003 knew what SDR was? A few of you. Yeah, maybe 10%, 15%. Today, all of you have heard of it, right? So we've come a long way in that period of time. SDR is now mainstream, whether you know it or not. Really, it's all about the software. Well, what are some of the things that we can do with software? I'll give you just a few examples. One of the first ones that people really were wowed by is that we could create true brick wall filters that did not ring when they were very narrow filters. If you've ever heard a very narrow crystal filter on CW, you hear the ringing. That's caused by phase distortion in the filter and intermodulation distortion in the filter. And that can be very fatiguing if you listen for long periods of time. Well, we're able to create very sharp phase shape factors. You can see the blue is the digital filter, and it is linear in phase. That means that you don't have the ringing. That's why it's, crystal filters are not linear devices. An example of an NRAD filter, you can see the same 500 Hz filter. Well, you can hear a lot of signals in the skirts of that green filter, if you think about it. So by also having digital filters, which are near perfect, we can vary the shape factor of the filter just with a little software control, and that allows us to trade off the sharpness of the filter with the time it takes for the signal to get through the filter. The sharper the filter, the more time it takes to go through the filter, and that's true of even analog filters. And if you see the controls up here on the right-hand side, by mode, we've added the capability of voice, CW, and digital having different shape factor filters that have different latencies through the filters just by selection, or you can let it be automatic. So that's something you can do in software. That's a feature that came in a later version than the radio did. So 4 or 5 years later, that feature got added to the radio. Another thing we can do is we can actually look forward in time in software. That may sound weird, but I can actually, because we're bringing in samples from the antenna, we can look at those individual samples from the antenna, and then we can process those signals mathematically, and we can eliminate some of the problems you have in analog. Like, have you ever heard of an overdriven speech processor on sideband? They splatter, right? Well, what if I could get the same talk power of turning it to 11, like everybody wants to do, but not have distortion? People think that in a contest it helps them get through if they turn it up to 11. It actually makes it so you can't hear what they're saying, if you've ever heard that. So in digital, we can do something called controlled envelope single sideband. David Hirschberger approached us, and he had written a patent on this technology that would allow you to have very high talk power. We can get up to 2.5 dB, which is almost doubling your power, without distortion. And we implemented it in practice in the radio, and first implementation of that was in our radios. And it's amazing how you can get through with without distortion. And you can see the blue is with it off and the red is with it on. Amazing what it does, and you just don't hear distortion. Another problem is impulse noise. This is like electric fences or power poles that are arcing over. We have one across the street from our office, literally right across the street, and it raises the 40-meter noise floor by 30 to 40 dB, excuse me, at 40 meters, 30 to 40 dB, depending on the weather. The weather changes it, you know, whether the humidity changes it. Well, that makes 40 meters unusable. Well, we looked at the problem, and on traditional noise blankers operate in say a 36 kilohertz narrow IF, very narrow bandwidth, which means the detection time is about 55 microseconds. Well, what happens if you see those CW signals, that narrow bandwidth causes an overshoot in that. You see the pulses of the signals? That's a fake pulse. And so noise blankers, traditional noise blankers, can trigger on those pulses. And you've heard it probably when you turn a noise blanker on and there's strong signals on the band. Well, how do you deal with that? And also, since software-defined radios tend to have very high-resolution spectrum displays, we want to get rid of that noise on the spectrum display that tears up the display. Well, if we can actually sample the signals at the RF antenna, then we can actually find the pulses in time, like on an oscilloscope, and subtract the pulses. So it's a linear process. Literally find the pulse, subtract it. And so hopefully I can actually demo this. I can't promise, we'll see if...
We were cool last night. We were in the high 40s last night, about 48. So we're getting into the fall weather. And some places
it's off.
the mid-40s last night. Then we warm up during the day.
It's going to turn it on.
The fall is on its way. Some of the leaves are beginning to show a little bit of color.
See it drop?
Nothing significant yet. It'll be another couple of weeks.
He's going to turn it back off. That dropped about 30 dB.
For the leaf watchers to come up and watch all the...
See it go up?
in Vermont. So we'll see how that goes.
He's going to turn it on again.
Two callers from the New York, New Jersey area.
See the difference? And the entire spectrum as well as the audio goes with that. So that's another thing that you can do. This is all done in digital hardware called a field programmable gate array. It's all done at RF frequencies, not at audio frequencies, but at RF.
Is that an intermediate frequency or is that the actual frequency?
The question is that an intermediate frequency? I think we're actually sampling 60-something megahertz. We're looking at 60 megahertz of bandwidth to do that. So you can think of it like an oscilloscope, and you find the pulse on the oscilloscope is one way to think of it in your mind. So I've given you 3 examples of software. These are all software things that got added to the radio after it was shipped through a download. So really, the old model of radio was you bought a radio and it was always the same, right? You might have had a firmware update, but no really new features, nothing like that, adding that noise blanker or those new filters and things like that. So the new model is, the old model was new radio equal new radio, right? Makes sense? Buy new radio, you get new radio. The new model is new software equal new radio. Literally, the capabilities of the radio can come with new software. So I think we need a minute of silence for the superhet. We've all owned them, right? Some of us maybe even built one. Who's that guy? Got it. Edward Armstrong. 1918 was the invention of the superhet. Now, superhets are still going to be around because we actually do it mathematically in software. We get rid of the hardware, all the mixing and so forth. And I like to talk about the real replacement is direct sampling will dominate the future. And I'll talk about why that is and what direct sampling is. Let's take a minute to look at a very simple version of a superhet receiver. We have a mixer on the front end that connects, you might have a preamplifier ahead of it, but in its simplest form, a mixer. with a bandpass filter, an IF amplifier, demodulation, audio, etc. And we have a local oscillator that in the early days it was a crystal, and now it's synthesizers in many cases. Well, over the time that became more complex, and where we'd have triple conversion. We'd go up to a 64 megahertz IF, and we'd come back down to 455 kilohertz and 36 kilohertz, and then run that into a DSP back in. Well, what we see is each one of those steps, like you'll see right here, there's a mixer, mixer, mixer. At each of these steps, we have amplifiers and filters and crystal filters. Each of those analog devices cause distortion, and the local oscillators add noise to the signal. They're analog devices, and they do that. So what can we do about the analog stuff that's on the front end of this radio? Is there a way to eliminate that? Well, that's what direct sampling does, is instead of those analog devices up front, we're going to eliminate those, and we're going to put a very high-speed analog to digital converter. In our case, it runs at 245 million samples per second. And what that means is that I can swallow all of HF at once. In fact, more than HF, up through VHF. And many of these converters can actually work up into the VHF, UHF, microwave regions by undersampling. So we can connect the A to D converter directly to the antenna, and what that means, I'm going from analog to digital in one step. Now, to think about sampling, all of us have probably owned a digital voltmeter. Most of us have. Some of us still have analog voltmeters. And if you can think about a sine wave where each of those black dots are a sample, and we're going to measure the voltage of that sine wave at that point in time, and we're going to save that as a digital number. That's what your digital voltmeter does. It has an analog to digital converter in it, and it looks at each one of those samples, and as long as it's sampling at 2 times the maximum bandwidth of the signal, I can perfectly reproduce it from the mathematical values. That's all you need to know about that. 2 times, and you can reproduce it. Well, you can see this one is many times oversampled. That's a lot more than 2 times. So it could handle a much wider bandwidth. So once we have that information as a number, then everything we can do in analog, we can do mathematically. There's math that goes with the analog radios, and that same math applies in the digital world. But there's new math that you can apply in the digital world that has no corollary in the analog world. That's kind of the interesting thing about it. There are things you can do in math that you cannot do in analog, at least not economically. So let's take a look at a modern direct sampling radio. In this case, the 245.76 megahertz input. And we take that and we're going to downsample it to 61.22. That was the number when you ask about the noise blanker. That's the bandwidth of the noise blanker, is 61.22. And within that, there's still mixers, but they're all digital, so that we can have multiple digital mixers and receiver chains, so we can have more than one receiver. In our case, we have up to 8 receivers independently that can be on different bands, different modes, all at the same time, because we're in the digital world. We can do mathematics multiple times in very fast processors. So the benefits of direct sampling is we get rid of all those analog and digital, those analog inputs and mixers and so forth. It's very straightforward today to get 100 dB or better of total dynamic range. This was very difficult to do in superhets. It's now been done, but it's expensive, and you have to have multiple crystal filters that are tuned very precisely to do that, and they're not inexpensive. And it's very straightforward to get 100 dB plus. And I will argue you never need more than 100 dB. If you'll see the charts ranking everybody, and we've got one at the top of the charts. It's just bunk, because it's at 100 dB you don't need any more. Really at 90 dB you're pretty well fixed at 90 dB. We can have precision real-time. You saw the spectrum display on that video a few minutes ago. You can have very high resolution real-time displays, better than test equipment that I've owned. You can have multiple receivers. You can have ultra-low phase noise, and I'm going to talk in a moment about why phase noise is important on both transmit and receive. And we can do digital signal processing at RF frequencies. That was the noise blanker operates at RF frequencies. And so we can do very high-speed processing at those frequencies. So let's talk about phase noise. How many of you ever pay attention to the phase noise in a QST review? A few of you do. What if I said that's one of the most important specs today to pay attention to? You probably didn't know that. In most superhets, it's the limiting factor in those radios. And what is phase noise? Every local oscillator, your VFO or synthesizer, has noise on it. And it's called phase noise. And phase modulation of a carrier becomes FM, right? And FM has sideband, right? It spreads out. If you look at a broadcast FM, it's 75 kilohertz wide, all the multiple sidebands. And so any noise in analog circuitry will modulate that carrier and create sidebands. Well, what does a sideband do? Well, let's say I have a CW signal with a very poor synthesizer. I apologize, you guys are behind me. I'll have to... What will happen is the noise on that CW signal will spread out, and if he's adjacent to you, have you ever heard a CW signal that was outside your pass band, but you hear him? You hear that's phase noise. You hear it a lot on field day. That's what it is. That's phase noise. It could be either on his transmitter or on your receiver, more likely both. So here's what that looks like. Here are multiple signals. You notice the weak desired signal. This is the signal we want to listen to. Well, here's a strong signal, and there's his noise sideband. You can't hear that signal, right? It's just not going to be possible. So in your receiver, your synthesizer, your local oscillator, your VFO, has that noise on it. And a very strong signal coming in on your antenna is going to mix with your local oscillator and spread your local oscillator so that even if he has a clean signal, it still sounds like phase noise.
I'll just interrupt there to say this is VK3 Alpha Mike Lima streaming on YouTube as well as transmitting on 147.475. This is a talk by Gerald Youngblood K5SDR on software-defined transceivers. Gerald is the president and CEO of Flex Radio Systems, one of the major manufacturers of software-defined transceivers, so naturally he's pushing the particular concept, but very justifiably, I think, and he's giving the reasons that software-defined transceivers will eventually become the dominant form. If you want to look in on the visuals associated with this lecture, please Google VK3AML 25 June 2022. Apologies for the slip-up at the start. Every now and then my streaming software changes its zoom rate for no apparent reason. So I've got that back right now. So back to Gerald Youngblood describing how phase noise is a major problem with superhets that is not such a problem with software-defined transceivers.
That happens inside your receiver. So that's number one. Let's say he has a dirty transmitter. Well, that dirty transmitter is going to spread all over the band. That's what it's going to do. And I'll show you. This is what a dirty transmitter looks like. This is actually a real measurement taken at a multi-op station, actually K9CT. And this was, you can see is about 2 kilohertz away. The noise floor rise is 35 dB. That's on a dirty transmitter. And you see all the spurs? Those are coming out, those are synthesizer spurs. So now let's look at, this is at that same location with clean transmitters. These are co-located Flex 6000s, 1500 watts. You can see this is a RIDI contest. And you can see the transmitter The transmitter's right here at 14.092.3 like that. Here's 14.082 clean. See there? So you can see how little phase noise there is across there. In fact, he can work within 2 kilohertz without any interference. At 1 kilohertz, you can hear it. Yes?
Superhet is vulnerable to phase noise on the local oscillator. Isn't a direct sampling RF system vulnerable to phase noise on the sample clock?
So the question is, if a superhet is vulnerable to phase noise on the local oscillator, isn't the same true for a direct sampling? And the answer is yes. The beauty of it, there's only one oscillator. It's at one frequency, it never moves, and we can get very high performance sampling clocks. Now you do have to spend more money on that, but you can get extremely good phase noise. It's much easier to do. So the answer is yes, you do have to pay attention to it. You'll find so here are comparisons right out of QST of various transmitters' noise. And so you can actually just go in there and plot the numbers, and you can see what they are relative to the carrier. I'm not going to go through the detail, but when you go through it, direct sampling radios are going to be in the best class. They really are the top performer in phase noise because of that very fact that I just stated. So here's a co-located field day situation. You'll see we have a sideband station here and a PSK31 station here. There's no interference between the two. Now, I will stress you have to have good antenna design. You can't put the antennas on top of each other and expect that to work, right? You have to have good antenna design as well, but you can do it without any filtering. This is with no bandpass filtering on the transmitters. So, audio quality. This is another thing that people are amazed when they hear, sometimes they hear a direct sampling radio and they think it's dead because it's so quiet. They're so used to listening to noise on it and distortion. Here's an example of, on the left is a 6300. This is a two-tone test. You see the intermod on the right of a popular superhet, and those are the IMD product, intermodulation, distortion, and harmonic distortion. You hear that. That becomes fatigue. If it's inside a crystal filter, you'll get ringing associated with that as well. So you just you can instantly see the difference in distortion products there. And these are real measurements.
What's your IP3 there?
The IP3 on these, IP3 is a meaningless number. It's a marketing number. What you really care about is two-tone, third-order intermodulation, distortion, dynamic range. That number is meaningful. IP3 is useless. I occasionally use it in design work of for analog circuits. So that's the real answer. It's a useless term. The ARRL is going to quit publishing it. They agree with that. So does Rob Sherwood. So the next thing is SDRs are really visual radios. And really, a picture's worth 1,000 words. This is a pile-up, RIDI pile-up on the right, CW pile-up on the left. And what's the beauty of it is you can actually see, like here in the RIDI pile-up, there's the station. This is the DX station right here, and that is the guy he's worked. Very easy to see the pattern. You can see 10 dB below the noise. They took a couple of Maestros and 6500s to Palmyra, and they said it totally changed operation on 160 meters and 80 meters because they could see signals 10 dB below what they could hear. QSB would bring them up, they'd double click on the signal, work them, there'd be another signal over here, they'd double click on it and work it, and the signal would fade below the noise floor. They had very weak signals on Palmyra. And that allowed them to work stations they couldn't work otherwise. Another thing is with software-defined radios, we can create an application programming interface. And to a software guy, that means that I can write code that completely controls the radio and operates the radio. So we created an open API, and what that is Smart SDR runs inside the radio. We have very high performance FPGAs, processors, server, Linux server, and so forth inside the radio, and there's a network connection, an Ethernet connection, and that that Ethernet connection has a plain English protocol. You can actually sniff it on the Ethernet port and read the protocol, and if you know how to know the protocol, you can control the radio. Then we put on top of that a library for Windows, and other developers have taken the Windows library, have ported it to iOS, to OS X, to Linux, to HTML5, etc., and written their own code. And I'll talk a little bit more about one of those applications in a few minutes. So everything that you see that we do in Smart SDR, a developer can do on their own on whatever system they want to write it on. All of those capabilities are available through the API. So if you're a developer and you want to have fun with it or do something serious, you can do that. We also added a waveform ADI. Yes, sir?
Yeah, on that previous screen where you showed the Windows computer, is that built into the radio or is that a separate standalone computer?
That would be a separate standalone computer, but it could be an iOS device, which I'll show you in a moment. It could be a Mac. We don't care. It really is agnostic of the operating system. Just needs Ethernet. Excuse me. Excuse me. Just needs an Ethernet port. The FlexLab, we have provided it to individual developers so they could port it. And there are ports now for several different OSs that are available. And I'm not personally as involved in which one and how that's done, but we've made it available to those people and they ported it. Does that answer your question? What?
It's a source code that you provide.
Yes. If you want to know more, come by our booth and we can talk more about it. So we also wanted to be able to add modes to the radio. Digital modes or could be digital voice modes. So to do that, and we wanted to make that open so that you could take open source code, even though our radio inside is closed, you could take open source code, wrap it, and then load it in the radio and have a new mode, or run it on a separate computer and have that. You can do it either way so that you can, that new mode, if you follow our protocol, it pops up in the mode selector in the radio. We started with Codec 2, which is FreeDV, digital voice, and we implemented that so that you can go load that module and it shows up as a mode. Then we implemented D-Star using the dongle. You plug it in the USB port on the back of the radio. We wrapped that in code, and we made that available so if you can look at that code and do your own waveform. So theoretically, you could put virtually any waveform. We have government customers that have put wideband encrypted kinds of things onto it that we have no knowledge of. They're able to plug those things in without us being involved in that. Back a little over a year ago, a guy who was the chief information officer for Aldi, which is the largest grocery store chain in Europe, he retired. He was an iOS programmer and said he wanted to just write apps. And so he had written some apps, about 50 apps for that, very successful for the iPad and iPhone. And he went over to help out another ham who he had never met set up his network. And that turns out that ham had one of our radios. He saw it and he said it was like the first time he ever held an iPhone in his hand. It was like, wow, this is going to change things. He said, I want to write an app. Well, what he did was independently of us, he took the open API and he wrote an iOS app that runs on the iPhone and the iPad. It looks very much like Smart SDR and it replicates 100% of the capability, and he's added other features that we haven't even added to it. And he flew over to see us in Austin and he said, I'd like to work with you. And we said, well, this is such a good product that we'll brand it Smart SDR for iOS. We'll provide first-tier support. You can provide second-tier support and continue to enhance it. We shook hands. That became Smart SDR for iOS. I can run it in this room and run a radio in Canada or Austin or Germany or whatever from here. So it's a pretty cool app. It'll run on your local network as well as remote. And that's an example of an independent person totally developing an application without our help. He even did the interface, all the low-level API work. And here's what it looks like close up. That's actually snapshotted that of a contest weekend. If you've heard of Mac Logger, the guy who did Don Agro developed Mac Logger, and he developed a user interface just like the iOS. He developed one for the Mac independently, and it's available as a product. WriteLog wrote to that interface too, and even the digital modes talk without any wires. They talk directly to the API. DX Labs is implemented. You're probably familiar with that one. Even built someone, a Brit built his own front-end console and interfaced all of that. He did it as a fun project. He goes around talking about it. We even had a commercial customer that wanted to track ships around the globe on the space station. They bought a couple of 6700s from us, ripped the boards out of the radios, put them in the, you see the rack right here? That's on ISS. That's a real installation on ISS. They racked it. They wrote all the interface software to do tracking. And it launched on CRS-9. That's the actual capsule, the Dragon capsule that was captured on July 20th. It had a docking collar. That was a part of the mission, was the new docking collar. And they loaded those in there. And every purple dot is a ship around the planet on there. Now, they do a lot more sophisticated, this is just a way for us to see it, but they do a lot more sophisticated stuff because they see the whole globe on every hour, so pretty cool stuff. And they're able to upload new software to those radios in real time and upgrade what they can do. Another commercial customer took a 6500 and turned it into a, let's see if I can say this, low probability of intercept vertical incidence ionosonic sounder. Anybody know what that is? Anybody ever hear a sweep across the spectrum? That's an ionoson. It's sounding the ionosphere because they're wanting to look at the, see the little swoop there? This is frequency. I don't know if you can see it. This is frequency, and that's height in kilometers. They're looking at the ionosphere because they're trying to look at propagation and find out sources of signals and how high it is and where it bounces and all those kind of things. So they were able to do that with an off-the-shelf radio. So there are a number of developers. We have way over 100 people that are doing something with it. It may be they just want to look at it. Some people are actually serious about it. Some are available. So I want to talk about, I mentioned the network is the radio. If the radio has an Ethernet port on it and has a Linux server in it, then the radio is a server. And if the radio has an API and it's a server, it opens up an amazing number of capabilities. One thing is I can have multiple clients. This is the rack with my radio at home. I have a 6700 and a power supply, not very sophisticated station, just 100 watts. The antenna control, and I can have multiple kinds of client devices. I can have a Maestro, which is a portable device. I can have an iPad, iPhone. I can have a PC, laptop, etc., Mac. And those can be connected either in my internal LAN or my external. This is actually my station. You can see I have a very small footprint Maestro right here. I have logging software here, and then the rack is here. So it cleans up the desktop. You can see quite a bit when you put everything under there. So that's my portable station. That's with a margarita on the back. And I just grabbed that Maestro, took it out there. It's Wi-Fi and battery powered. I can run it 5 hours on a cell phone charger battery. Here's another customer that actually ran the ARRL from his backyard. Just took it out there, took his laptop, ran ARRL. So you can really pick the best tool for your task. It can be any of these kind of client devices. It doesn't even have to have a client. In the commercial application, there is no user interface. It's talking to a computer that's gathering data. Doesn't matter. So let's talk about one client device, Maestro. We had traditionally our radios used a PC as the interface, and we found that there are people that are just not comfortable with that. They want knobs and buttons and so forth. They're also, if you're doing contesting or serious DXing, you probably need it for workflow. Although your hands should typically be directly on the keyboard and never leave the keyboard, but occasionally you do need to do that. So we created this device. K9CT and 403 Alpha collaborated with us on exactly what the knobs and buttons need to do. I also personally interviewed a dozen contesters and DXers who were not our customers. And I talked to him and said, what do you like, what do you not like, what's a problem in your workflow? And one of the big takeaways were, I got too many knobs and buttons, I screw them up, they do 2 or 3 things, I push it, and 12 hours into 14 hours, 24 hours into the contest, I can't figure out what I've done. So make knobs that are fat finger friendly, and make them so they do only one thing. I only want what I need all the time. So what you see on the right, now this is much bigger than you can think. That's an 8-inch screen. That's an 8-inch touch screen. So if you see it, everybody says, wow, that's bigger than I thought. And you notice how much room there are between the knobs and buttons, and they're only the things you need. So that was the philosophy. Anything you use occasionally should be one touch away, and we use the touch screen. That's the philosophy. And you can see we have full controls for slice A and full controls for, that's VFO-A and VFO-B, and good sized knobs, and it's easy to know what you're doing. You can just sit down at it. Here's, this station won the RIDI contest using Maestros, and this is probably one of the best RIDI contest stations you'll ever run across. 10 million points there. We can also do seamless station integration. What I mean by that, and I'll show you pictures before and after. One of the things we want to do is, if the radio is a server, you really don't want to have something else connected to make all your station work. You'd really like to be able to control your antennas, your tuner, your amplifier, all those peripherals, and have them all switch automatically. Well, what we did was we have 2 USB ports on the back of the radio. With one of those ports, you can control an entire station, and I'll show you an example of that. This is W4AX in Atlanta, and you can see the Maestro. You can see on the lower right, he's got a 6700 down here, and this is his control setup. So he has a single 6700, he runs that to a 7-port USB, and from that we can control USB to serial for CAT. We can control BCD and binary, single bit control. So his entire station is automated, I think, through 900 megahertz. So basically 137 kilohertz to 900 megahertz. I talked to another customer who walked in the booth in Dayton. He had his iPhone, and he said, I can run 137 kilohertz to 24 gigahertz. All bands, all ham bands, all automatically switch with power amplifiers. I said, that's impressive. And he's doing off that a single USB port. He's controlling that entire station. Mac even controls his on the air over here. See, he's got this W4AX, he even controls that off of it. You can also integrate all kinds of digital things. CW is a digital mode. You've heard of CW skimmer. What if I could have 4 CW skimmers on one radio, all on each on a different band, all decoding, and with a single click on any decoded signal, QSY transmit. Click on another band, QSY transmit. That's what you can do. And you know how many, so I can operate and skim in one box. I can have up to 4 and 192 kilohertz receivers. I can stream to the same computer or to separate computers. It can run, skimmer can run on a different computer. It can be anywhere. You can even create your own spots. And that's how many wires you need. None. No boxes, nothing. Here's an example of that. We've got 2 skimmers in this case with Smart SDR in the center, and you can see we're skimming 2 bands at one here. So that's how many cables you need to run all that stuff. 0, keiner, zilch, 0. You can run digital modes in the same way. I'm going to speed up just a little bit. This is RTTY setup here with two N1MM RTTY instances. You can be operating on two bands at once, in fact. You can be transmitting CQ on one band while you're S&P on another band on RTTY. Same number of cables, none. Here's a before and after. This was a, how many of you know what single operator 2 radio, SO2R are? Okay, that's what I just described. I'm transmitting on one band in a contest while simultaneously tuning and listening on the other band, looking for multipliers and being able to hop back and forth. Traditionally, that's taken 2 radios and a bunch of boxes to do that. This is a traditional setup. This is the replacement setup.
And this is VK3 Alpha Mike Lima with the regular Saturday night test transmission, currently streaming on YouTube live stream and the audio on 147.475 of a talk by Gerald Youngblood K5SDR, President and CEO of Flex Radio Systems, talking about the future and the application of software-defined transceivers. Back to Gerald.
Same station. Before and after. One Maestro, you're on 2 bands, clean setup. Notice the knob is right by the keyboard. Notice where the knobs are back here. They're way up here and all around. So changes the workflow. Here's the before. How many of you have ever seen anything like that?
That's my station.
All right. That's an SO2R station. I can do that kind of capability. After. Does that look different? Do you think that would be more reliable? Fewer RF loops, ground hum and those kind of things. And that's all modes, digital, CW, sideband, etc. Make it simple. This is that station in the worldwide RTTY. You can see there, this is multi-2. The CQ run operators are the 2 guys in the center. The S&P are the outer guys. Whoops, let me go back there. So the 2 guys on the outside are doing S&P, and you'll notice a bell in the center there. The guy rings that every time he hits a multiplier. So there's a little bell there. It's a sport. It's a team sport. So it's a lot of fun.
USB spigot on the bell.
Yeah, USB spigot on the bell. That could be done, I guess. Yeah, sure. That sounds like a good hobby project. So what's new? Let me take a few minutes to talk about what's new from us. The first thing I want to talk about is that I mentioned earlier some people want knobs on the radio. Well, we created Maestro, which is a portable device. You can use it in the shack, or you can use it on the back deck, or you can take it to your office and use it from the office. Well, so we took that same capability and we've integrated it now in the radios. We've come out with 4 new models. 2 of them have the integrated Maestro front panel built into it. We've also taken what we've learned over the number of years in direct sampling and enhanced some of the capabilities, taken the feedback from customers, and come out with these 4 new models. This has an 8-inch IPS touchscreen display on it, and it's 1920 by 1200. That's the highest resolution display you'll find in anything like this. And it will also drive an external HDMI monitor, so you can have a big TV screen or whatever and drive it at full resolution, not any shabby kind of 1980s resolution. So we come out with the Flex 6400M and the 6600M. The M means it has the Maestro front panel. We also have 2 models that are the 6400 and the 6400 and the 6600. These are, if it's a 6400, it's the same radio whether it has the M or not inside the radio, and same thing for the 6600. But you can get it without it. We have people that buying Maestro plus the base model so that they can have the small footprint and take it around. You saw in my shack, I don't have a lot of room, so I just like the Maestro. So you can do it either way. You can buy it with the front panel plus a Maestro, either way. So both of these models run Smart SDR. Everything I've talked about is applicable to these radios. They have improved receivers. They have the two full VFO knobs. I mentioned reciprocal mixing dynamic range. These have 116 dB, which are about 10 dB higher than anything else I've seen on the market, 5 to 10 dB higher. They both will run full duplex, meaning I can listen while I transmit. If I have enough transmitter isolation, I can do that. The 6600 adds contest band preselectors. 160, 80, 40, 20, 15, 10 have higher performance preselectors. Why would I want that? Well, if you've ever been in field day, you might want extra rejection from the day, or if you're in a contest station. They give you at least 50 dB and in many cases 60 dB of isolation between the contest bands. And we can also, on the 6600, digitize two antennas at once. That's how you do single operator 2 radio. It also, you could have a 6-meter antenna and a tri-bander being listening at the same time and monitoring those bands without any interference from between the two. So the M models have all the capabilities of the base radios, plus they integrate the display and the HDMI. And they provide all the touchscreen controls and has the ergonomic design that I talked about earlier. And they all provide SmartLink remote integration, and I'm going to talk about that in just a second here. And you can use them all with Maestro, iPad, iPhone, dog park, etc. So here's the back end of the 6400. It has extensive connectivity for input-output. It has a dedicated receive input as well as a dedicated transverter port, but it can also be used as a receive port. You can add a GPS discipline oscillator, which means you can have very precise frequency control, which is really important for microwave, and some of the ESSBers like it. It also, if you have the M model only, it gives you the HDMI port on the back. The 6600 adds a second receive input. I mentioned you can digitize two antennas at once. You can do diversity as another application for that. It has two transverter inputs, which is, I think, unique. But you can also use those as receive inputs. So you could have 4 receive-only ports on this radio, plus the 2 transceive ports. I'm not going to try to read all that to you. I think the main points are that with the 6400, you get 2 receivers and 2 pan adapters. The pan adapters can be up to 7 megahertz. You can zoom in very narrow, but you can also go out to 7. It's 14 megahertz with up to 4 pan adapters on the 6600. So you could be on multiple bands, chasing DX multiple bands. We've also come out with the Power Genius XL that will start shipping in October. This is a 2 kilowatt, 30 pounds with the power supply built in. And it is true 1.5 kilowatts out. You can run SO2R RIDI in a contest without power back off. You can run AM at 1500 watts PEP, real. So it has the latest vapor phase cooling heat sinks in it. It has Diplexed filters, if you know what those are, so that the harmonics dump into a dummy load. Typical harmonic rejection is close to 70 dBc, which makes a difference. It changes its mode of operating mode, depending on your mode. If you're in single sideband, it's in class AB, which is the lowest efficiency mode, but gives you best linearity. If you go into RIDI, it changes the voltage and the bias on the transistors. The power supply is completely controllable, so you get up to 70% efficiency on RTTY. So combining the heat sink capability with the higher efficiency, we can run continuous RIDI or AM, which is, I don't think, true of any other amplifier on the market. And you can carry this on the plane. I've carried this device on the plane with me. It's 30 pounds. And it has a 3 kilowatt switching power supply like they would put in server racks inside of it. I was wrong, 33 pounds, excuse me. It'll run on 110 volts or 220. You reduce the power to 110. It's like 800 watts on 110 volts, but you can just plug it into either. True SO2R, I can be transmitting at 1500 watts and listening on another band without causing problems. I don't think any other device can do that. You can run it with any radio, any other manufacturer's radio. It does CAT, CI5, BCD. With our radios, it connects by Ethernet. So all you need is RF and Ethernet. Through the end of the year, it includes Tuner Genius, which is an external tuner that will do 15 ohms to 200 ohms at 2 kW, complex impedance. This is the back. You can see that. It has 2 inputs and 2 outputs, so you can do the SO2R. So let me talk about SmartLink for just a minute. One of the things, when the radio is a server, you really want to be able to run it remotely. And we've added that capability with version 2. And we spent a lot of time to make it simple because there have been remote capabilities, but they haven't been simple.
This is VK3 Alpha Mike Lima streaming on YouTube and transmitting on 147.475. If you want to look at the visuals that go with this lecture by Gerald Youngblood K5SDR, the President and CEO of Flex Radio, please Google VK3AML 25 June 2022 or look for my YouTube channel Oz Radio Historian, AUSRADIO HISTORIAN, all one word, Oz Radio Historian, AUS. Back to Gerald Youngblood.
And we wanted something that you could just plug it in and turn it on and use it. And so really the setup is I register my radio. I want to know that I physically have the radio, so we say push to talk. I physically own the radio. We don't want somebody hacking in and gaining control of your radio, so you have to have physical control of your radio. You register it within 15 seconds, and then it says you're now registered, and at that point the radio will show up in the chooser, and if I'm lucky, I can show you that. You'll see right here, that's the shack at our station in Austin. And I'll cross your fingers, we're on hotel Wi-Fi. I have no promises as to whether this will actually, it worked. That's our station, K5FRS in Austin, over hotel Wi-Fi. Works a little better. So you can see I can tune the station from Austin. Yes, sir.
What kind of security do you have on it, like SSL, TLS, or
Just a minute. I'm going to mute it for a second. The question was what kind of security? I'm not a security expert. There are people at our place can answer all the buzzwords on that. You can use two-factor authentication. I think we use Auth0. Does that ring a bell? AUTH0 or bracket? Anyway, we're using the latest stuff. You can use. You can create a custom login. You can use. I use my Gmail account. You can use Facebook. You can also do port forwarding if you want to do that. So you've got all those capabilities. I just use my Gmail account, logged in, it automatically logs in. You saw how many stations were on there? We have a set of social stations. I could have logged into Toronto or Austin or Atlanta. I had several of those stations that I can log into. And you can see I have real-time display. That's a real-time pan adapter over the hotel Wi-Fi, over the internet, just like that. 5? Okay. Got 5 minutes. I'm amazed that actually works. Usually Murphy's Law strikes you down here. So it pops up in the chooser. You can choose it. I can do that same thing. I can bring my iOS application up here, run that same station right here in front of me if I had time on that app. We also added pop-out pan adapters. N1MM has a capability of streaming to its display and posting the spots on it. So we added that capability in the latest release, and that's available. It got used on Palmyra as a stowaway, and I told you the story on that. But I think what's important is that we're now going to the most remote place on Earth, Bouvet. We've shipped 14 Maestros and 13 6500s, one 6700 to be set up at K9CT, and those will be shipping out soon to Bouvet, which is the most remote island on Earth. It's also the #2 most wanted, #2 to North Korea, and I don't think any of us are going there soon. So I think we'll have to wait on that one. So we're proud of that. We're also gold sponsors of WRTC coming up next year, which is the Olympics of ham radio. And we have a number of stations that we'll be using, and they've actually expanded the rules to allow some of the pan adapter spectrum capabilities that they didn't allow before. So we're real pleased with that. So 2013 is where we started, 2017 is where we are. You can see a lot's happened since those little 3 boards. So we're really proud to be part of that and help people rediscover radio. So thanks so much for coming. Did I actually make it on time? I did. Wow. That was 106 slides.
Gerald Youngblood K5SDR, with apologies to him if he's watching for the slight stuff up. Every now and then OBS streaming software jumps to the wrong zoom, and I have to fiddle the sides of the picture to bring it into the correct zoom. But Jerry there describes many of the advantages of software-defined transceivers, of which his is up there with the best of them. Well, we promised a coverage of over-the-horizon radar, and specifically the JINDALEE Australian incarnation of that. And I can't, of course, give you any secret material with regard to JINDALEE or any classified material. I don't have any. But a lot has been published in bits on the web, and I can bring together some of the more important video coverages and descriptions from there. One of the first I'll show you is from the Old Flyers group at Jandakot, Western Australia. That's the Royal Aero Club of WA, and one of their members describes very vividly, I think, and in a very germane way, the operation of JINDALEE. We also have clips from the Defence Science Technology Group in South Australia, from Lockheed Martin Australia, and finally from a Chris Moyer, who works for ANSYS government initiatives in USA, talking about ionospheric modelling programs that allow this sort of radar, over-the-horizon radar, to work. So without any further ado, over-the-horizon radar, initially presented by the Royal Aero Club of South Australia.
Hello and welcome. The continent of Australia has a massive coastline of 59,736 kilometres. Western Australia's coastline accounts for 20,781 kilometres of that. The length of Australia's coastline represents 51% of the Earth's circumference. Amazing. The ability of Australia's maritime and defence organisations to mount surveillance over such a distance is a challenge. No wonder that Australia is a world leader in high-frequency Skywave over-the-horizon radar technology. This technology had its beginnings in early research into the ionosphere conducted at Weapons Research Establishment from the 1950s. Subsequently, the JINDALEE high-frequency over-the-horizon radar became a core research project from 1970. Unlike traditional radars that were limited by the line of sight, the JINDALEE high-frequency radar used the ionosphere above the Earth's surface. A high-frequency radio signal was beamed skywards from a transmitter and refracted down from the ionosphere to illuminate a target. The echo from the target travelled by a similar path back to a separate receiver site. Received data was processed into real-time tracking information. In 1971, John Strath advocated strongly and successfully for funding for a scaled-up prototype.
The story goes back to 1969 when I prepared a series of information papers for the Chief Defence Scientist dealing with the problem of air defence of Northern Australia. An attempt had previously been made to mount such experiments, and unfortunately these were unsuccessful, and we had to demonstrate that there were good reasons why we should succeed where others had failed.
The first experimental radar, designed and built by Defence Science and Technology Group, was constructed at Alice Springs in Central Australia in the mid-1970s. JINDALEE A was modestly powered and had a narrow field of detection, a staring beam with a simple whip antenna array only 1/4 of the length of the current Alice Springs JINDALEE radar. JINDALEE A did detect aircraft at long range and later ships. Its radar waveform generator was one of the few pieces of Australian-developed original equipment retained in later JINDALEE stages. In the early 1980s, JINDALEE B, costing some $30 million, was developed. It was higher-powered, covered at least 60 degrees, had radar track white scan capability, and an advanced automatic frequency allocation system. In 1986, approval was given for the design and development of the over-the-horizon radar network. A network of these installations would be constructed covering the approaches of Northern Australia. That same year, the operational radar JINDALEE C was handed over to the Royal Australian Air Force. The rugged demands of operational life had been allowed for by re-engineering by BAE Systems, formerly known as AWA. In 1991, the Commonwealth awarded Telstra a prime contract worth $860 million to design and construct the JINDALEE operational radar network. Telstra awarded major subcontracts to GEC Marconi and Telstar Systems, a joint venture between Telstra and Lockheed Martin Corporation. Phases 3 and 4 of the fully fledged defence network were operationally released to the RAAF and formally accepted in 2003. By this time, the new capability consisted of 2 radars, Radar 1, located in Queensland, and Radar 2, located in Western Australia. The original JINDALEE radar at Alice Springs continued to be operated as a separate system by the RAAF. The network was Australia's first comprehensive land and air early warning system, providing a 24-hour military surveillance of the northern and western approaches to Australia and serving a civilian purpose in assisting in detecting illegal entry, smuggling, and unlicensed fishing. Illegal entry by non-citizens who arrive without visas to enter, smuggling of contraband, and illegal fishing in Australian waters are ongoing off our northern coastline. Thank you for watching.
And now an item from Defence Science Technology Group, a failed Australian DSTO. In the 1950s, early research into high-frequency radar at DSTO Edinburgh, South Australia, reveals potential for over-the-horizon surveillance. In 1969, TTCP membership and papers by John Strath prompt development of a core over-the-horizon radar project.
In 1969, when I prepared a series of information papers for the Chief Defence Scientist dealing with the problem of air defence of Northern Australia. An attempt had previously been made to mount such experiments, and unfortunately these were unsuccessful, and we had to demonstrate that there were good reasons why we should succeed where others had failed.
In 1972, over-the-horizon Project JINDALEE began as a concept demonstrator only. In 1978, the DSTO proves the feasibility of JINDALEE over-the-horizon radar.
JINDALEE has a large experimental program comprising about 60 separate tasks involving the radar and frequency management systems.
The role of the frequency management system is to provide the best frequency for the radar to work on in order to see the targets in the region in which it's looking. Specifically, what we attempt to do is to choose the frequency which would yield the highest signal-to-noise ratio on those targets.
The radar is operated in several distinct modes. The most important are for aircraft and ship detection. We detect and track international aircraft flights as well as those within Australia. We track ship targets of opportunity off the north and northwest coasts. In addition, we've carried out trials with the Air Force aircraft and naval vessels.
From 1990 to 2003, JINDALEE Operational Radar Network was announced. JORN, JORN, successfully entered operational status. And there we see some scenes of the coordinating at Edinburgh, South Australia. Today, JINDALEE greatly enhances surveillance for defence, Coast Watch, customs and other government agencies. Using the ionosphere as a bouncing medium to detect ships and airplanes over the horizon. There are the three coverages, obviously, of Northern Australia, given by the three JINDALEE transceiver stations.
While threats may lurk beyond the horizon, they are not beyond the reach of technology. The men and women of Lockheed Martin Australia support a stronger nation through their work on the JINDALEE Operational Radar Network, or JORN.
It works by transmitting an exact frequency that we know we can bend through the ionosphere. It is then reflected off any boats or planes, and that makes up the radar picture, which is fed to the RAF operators.
We maintain and sustain these radars while evolving their capability and performance. Over the course of our 25-year involvement in JORN, we've invested in innovative and homegrown technologies, like our Research and Development Alliance with the Defence Science Technology Group. This collaborative effort, Project Coorong, quickly delivered significant next-generation over-the-horizon radar outcomes in 12 months. We're supporting technology solutions created by Australians, integrated in Australia, and protecting Australian sovereignty. And Lockheed Martin Australia is part of the world-leading team in managing complex systems development and integration.
I like being involved in a radar system that is one of the most sophisticated and highly developed radar systems in the world, and that we are actively contributing to the defence of Australia.
Now and in the future.
This is VK3 Alpha Mike Lima, and we're talking at the moment about the JINDALEE over-the-horizon radar system used by Australia to monitor its offshore incursions of various types. Now, so far, the very populist accounts that you've got from the advertising, I suppose you'd call it advertising, of the various people involved with the JINDALEE project, hasn't given any sort of meaty analysis of the way the system operates from an engineering point of view. And I have to be careful, of course, of what I say about it, because it's the monitoring of incursions on our borders is fairly political, but there was a description published in 1994 of the JINDALEE project as it stood then in the IEEE's proceedings of their HF Radio Systems and Techniques confab, the 6th International Conference at the University of York, UK, and this was in the middle of 1994. So while this is material, a description that's 28 years old, it does generally give an impression of how the JINDALEE over-the-horizon radar system with its 3 stations in Australia works. And I'll read it from the paper, Architecture of an HF Skywave Radio Network, that's written by T.A. Soame of GEC Marconi Systems Australia and R.K. Jarrett of the Telstra Corporation. I'm reading this little section of it under the fair dealing provisions of copyright. And here goes. Radar architecture. Physically, each operational radar comprises a CW transmit and a receive site separated by around 100 kilometres. The transmit configuration employs 560 kilowatts of transmitter power, which can be split into 2 halves. Assuming full aperture of the transmit site is selected, the 20 kilowatt solid-state transmitters feed an array of vertically polarised log periodic antennas on a 200-metre ground screen. For the high band, there are 28 antennas in the array. At low frequencies, the transmitters are combined pairwise into 14 low-band antennas. Electronic beam steering is accomplished by a combination of phase and time delay at low signal level, the arbitrary CW waveform being generated digitally. The receive site is dominated by its 3-kilometre long line array of dual monopole antennas, and this is what this photo shows. To each phased pair of monopoles is connected one receiver, 480 receivers in all for a 90-degree configuration. The Marconi receivers digitise the signal after 2 mixing stages and perform the bandwidth compression in software, again with digital waveform synthesis for each receiver channel. Using this configuration, the radars achieve not only the extremely high dynamic range needed for the HF band, but also avoid internal noise limiting even in the quiet Australian outback environment, thus giving the radars extraordinary sensitivity. Operationally, as the transmit beam of typically 10 degrees is step-scanned around in azimuth, the receive site co-steers a cluster of perhaps a couple of dozen fine finger beams of typically 0.5 degrees width to overlay the transmit beam's footprint on the Earth at the correct range. So you have the co-steering of transmit and receive sites separated by a 100-kilometre baseline. Signal processing performs Doppler analysis on those received beams so that in all, some 100,000 to 1 million range azimuth Doppler cells are assessed for the presence of a target in each radar dwell. The signal processing also provides suppression of burst noise, lightning impulses, meteor echoes, narrowband interference and broadband interference, so that the radar continues to perform robustly in the frequently malign environment. Automatic detection and tracking, automatic multipath combination, and automatic coordinate conversion to ground range complete the target processing. Comprehensive operator validation and editing facilities enable the operators to assess these automatic processes and override them if necessary. To support the radar operation requires a detailed knowledge of the ionosphere, so that the chosen operating frequency provides the optimum radar performance. An array of frequency management subsystems are used which are either co-sited with the radar or use remote sites. That's, of course, to determine the height of the reflecting layer. Well, that's just a short resume of the very complex techniques that are used with JINDALEE. As I say, this is a published IEEE description of the system, so I'm not breaking any protocols or breaking, I hope, any security releases, but this generally gives you, I think, a good idea of exactly what JINDALEE is, how it protects our borders, and what it's used for.
Hi, I'm Chris.
Now, I'll run a quick coverage of an edited version of this presentation by Chris Moyer of the ANSYS Government Initiative section, US National Security. It's on YouTube, so it's quite public. And he talks about the systems toolkits that they've developed for determining the height of the ionosphere and accurately aiming over the horizon radar.
Moyer. I work in the SDK development with the communications and radar module. I've been here at AGI for 14 years. My forte is communications and radar systems. I'm here to talk about the SDK over the horizon HF model we incorporated with SDK 12.1. It is an incorporation of VOACAP model. VOACAP is a slightly modified version of IONCAP, which stands for Ionospheric Communication Analysis and Prediction. This allows the prediction of skywave propagation effects. What is skywave? Skywave is a signal when it enters the ionosphere. The ionosphere will bend it back down to Earth. And this provides long-distance communications or long-distance emissions, and it can be even considered global communications or global emission. The ionosphere is a very dynamic in nature. It will provide changes in signal based on frequency, based on transmission, and the entire solar effects. So it has a solar cycle dependency, which is an 11-year period. It has a seasonal effects, which is the Earth's orbit around the sun. It is also dependent on the diurnal, which is the 24-hour rotation of the Earth, and latitude, as well as hardware aspects such as transmit and receive frequencies and transmit and receive angles. So I want to just discuss a little bit about the transmit and receive frequency and angle dependency here, because there are some very basic aspects. If we have a transmitter here on Earth and we send a signal up into the ionosphere, we have an ionosphere here. The ionosphere actually consists of multiple layers. Let's see, you can't quite see that. Let's do this here. The D layer. We have an E layer. We have an F1 layer. And we have an F2 layer. And the signal will refract differently through these different layers, and it will depend on these aspects that have been mentioned right here. So if we send, let's assume our frequency is fixed. So our frequency is some constant, and we send a signal up into the ionosphere at some angle. It'll hit the ionosphere and it'll refract back down to the Earth. Now if we keeping that frequency the same and we just change our angle a little higher, it's going to enter and it'll refract again and it'll come back down at a different location. Again, a little higher of an angle, and we'll come back down to the Earth. Eventually, if we go too high, this won't refract back down, but it'll continue on through. Thus, there is the notion of some critical angle, and that critical angle is when the signal continues to go right on through the ionosphere. But what we notice is, if this was theta 1, theta 2, theta 3, each of these angles are increasing. So we see as we increase our angle, our range, we cannot extend quite as far. So let's keep that in mind and erase all this. And let's take a look now at the frequency aspect. So if we have our emitter here, and we're now going to assume our angle of transmission is a constant. So if we have our ionosphere here, let's draw something here. We've got our 4 layers. Transmit at some fixed angle and at some frequency. And if our frequency is too high, it's not going to refract back down and it'll go off into outside the ionosphere. This frequency is, we'll call a critical frequency, just like we had a critical angle. So if this critical frequency, our frequency gets too high, goes above the critical frequency, we lose all signal. So this introduces something that we're going to call a maximum usable frequency, or MUF for short. If we transmit at the same angle, but a slightly lower frequency, we're going to end up refracting back down and we'll hit Earth. This frequency is, we'll call it the maximum usable frequency. So that is the maximum frequency before we end up hitting that critical angle and we no longer receive a signal back down. We send another signal up at a slightly lower frequency and we refract back down. So we'll call this frequency 1 is the maximum usable frequency. Frequency 2 is less than frequency 1. We'll transmit another signal at the same angle, slightly lower frequency, and we come back down and we have frequency 3 being less than frequency 2. And again, if we transmit at the same angle but a lower frequency yet, we don't receive anything back down. This frequency, frequency 4, being less than frequency 3, introduces a new concept called a lowest usable frequency. And this will happen because there's too much, this lower layer is the D layer. There's a lot of absorption that takes place there. Your signal is basically being hitting a lot of the atmosphere that's in that lower layer. A lot of molecules in there, particles, they start colliding. You end up absorbing, they end up absorbing your signal. So
anyway, that was a part of a lecture by Chris Moyer of ANSYS Government Initiatives, US National Security, which is on YouTube, publicly accessible. And I see it's 11 o'clock, so we normally open up at this time for QSOs. This presentation on principally on the JINDALEE project, the Australian Over-the-Horizon Radar, or it's called the JORN, JORN for short, JINDALEE Operational Radio Network, now that there are 3 stations, Laverton, Western Australia, Alice Springs, Northern Territory, and at Longreach in Queensland, coordinated, I think, from Edinburgh in South Australia. So we have quite a sophisticated, cutting-edge HF technology that's keeping Australia safe from smuggling, from undetected incursions of people on our northern and northwest coast, which is so difficult to surveil in any other way, and done for a reasonable price. So I think we can be very relieved that this technology has been developed in the last 40 years, particularly with increasing troubles to our north. Interestingly, when I was in New Zealand about 3 years ago, I set up an 80-metre receiving station on a beach on the west coast of the South Island in New Zealand. And I couldn't hear anything from Australia for the noise, the racket of an over-the-horizon system. Now, obviously, the Australian systems are not beaming anything like the direction of New Zealand. So I had to look around the world for over-the-horizon radars that were. And sure enough, China. The Chinese radar is audible on our 80-metre band from time to time, not very strongly, but they beam that out into the South China Sea for reasons that'll be obvious from anybody who reads news reports. And the second and third hop, it would be landing on New Zealand. So that's the reason I had so much trouble there. Anyway, this is VK3AML with a regular Saturday night test transmission. I hope I haven't bored anybody too greatly. You always get the cynical comments on the live stream talkback. And incidentally, I'll give a wider view of the shack. Just hang on. Now that we have the two cameras, I might as well make use of them. There we go. And hello to camera number 2 up on the shelf way behind me. Just for your information, I am rewiring all of this at the moment. The material to my right, the transmitters there, have always been a mess on that table. I have a low-level 19.5-inch rack that's going in there over the next few days, and HF receiving and VHF transmitting gear will be located in it, so that I'll be able to interconnect a lot more in the way of equipment via that appliance. So at this point, this is VK3 Alpha Mike Lima changing his monitoring system as always. I always forget to do that. I have to listen off the mixer, not off the receiver, because I'm trying to receive people off 2 meters. There we go. So VK3 Alpha Mike Lima calling CQ and standing by for any calls on 147 475.
Yeah, VK3 Echo Charlie Golf.
And VK3 Alpha Charlie Zulu.
We've got VK3 ECG. Nice to hear you there, Dave. And VK3 ACZ Peter. Anybody else to join us? VK3 Alpha Mike Lima. No further takers. Anyway, Dave, how's your week been? I hope the material tonight wasn't too boring. Whenever it gets into contesting, I don't feel too happy about it. I'll just switch back to the close camera now. I still haven't mastered all of this technology. Wait a moment. There we go. Back on the close camera. But very many thanks to Mick Maxwell, VK3ADD, for throwing a webcam my way that he could no longer use. Just happened to be the same as my webcam. And though I can intercut between the two in OBS software, not terribly, with not terribly much adroitness at this stage. I really need to have a switch to do that, not a mouse and a screen. VK3CG, how's your week been, Dave? VK3AML.
Yeah, VK3AML in the group, VK3CG, and good evening to you, Peter, as well. Yes, no, a pretty good week. I'm fairly busy doing bits and pieces and things like that, and long, complicated online meetings this week, but otherwise all good. No, I really enjoyed tonight, actually. A good chance to hear a bit more about the details of SDR, other than the sort of brochures type exhorting of the quality of the system. And although their talk clearly was, promoting the system, there was a really, a good, solid interest in the background of what's involved. And I think, as you said, I think it was more than just an advertorial. It really was a good illustration of some of the advantages. And I suppose that, I'm sitting here with, I think, 2 rigs that are essentially SDR based, if you like, though some of them are not complete, and an older superhet sort of system, and that's in fact what I'm using on 2 meters. But the thing I've been playing with a bit this week is the software for my little IC 705, which is a piece of software written by Marcus Roskosh, who has written a piece of software for, I think it's for Macs as well, but it's also available, and PC, but I think it's available, well, the one I have acquired is the one for the iPad and the iOS version, and that allows me to control my IC705 via Wi-Fi. So my IC705 is connected to my house Wi-Fi, and so any device that connects through my home Wi-Fi, including across the internet, can control that transceiver, and that's everything on all transceiver controls in essence. I mean, I'm sure there's a few things you can't get into. You can't get into the details of the menu system, but you can certainly have obviously the speaker and the microphone through the system, all control mode and frequency and bands and memory channels and so on and so forth are all there. It's got a few little rough edges, and updates are being released fairly regularly. We have to remember to put the microphone and back to the rig before you turn it off. Otherwise, you can find a bit of difficulty finding your microphone afterwards. But it works extremely well. I did have some initial problems with it, with a lot of drop data, but that was largely because I was running two Wi-Fi networks, and although they are linked, the networks, I connected to the wrong network initially, and obviously it was going through a bridge and was getting lots and lots of dropped packets. As soon as I connected to the right network, then that was fine, and the quality seems pretty good. So I can wander around the house or be some other part of the house, and in theory, of course, remotely as well, and access the radio. Of course, you've got to have the radio obviously, turned on. You can't turn the radio on remotely and things like that, but that's not too much of a challenge. So that was a bit of fun. So I've been playing around with that, and it's got a number of sort of built-in sub-apps as part of the SDR control software, which includes DX clusters and hotspots and so on, which all appear on the waterfall display. So you can connect the DX cluster, see what stations are on, and have those stations and frequencies actually shown up on the waterfall display. So you can tune to them if you want to. There's a built-in FT8 system for it, and there's a logbook and a whole variety of things to be able to do as well. So really quite interesting, a bit of playing around with that and learning effectively what it can do. Anyway, back to you, VK3AML and the group VK3ECG.
VK3CG and group VK3AML. I just gave a pause there in case anybody wanted to call in addition to yourself and Peter. People are always very welcome to call in if they so desire. And just before I answer what you said to what you had to say, Dave, some people here talking about the JINDALEE project covering to some extent the Indian Ocean, and one wonders whether they have any record or whether they were looking in that direction at the time. At the 8th of March 2014, the day that that Indonesian, was it Indonesian, I think, plane completely disappeared off the face of the earth and is believed to have dived into the Indian Ocean somewhere. I wonder, did they keep any records? One never can tell. But it would appear from those maps that their coverage extended out that way, which is interesting. The pirate on our text chat saying confidential information is no longer confidential when made public. Well, the material that I've put up on JINDALEE today is stuff that's either published 25 or more years ago by the IEEE, which God knows is not a secret organisation, or YouTube or internet, and has all long since been made public. Ardran from America says that the Signal Phantom YouTube channel has some waterfall and audio videos of various OTHR. That'd be very interesting to have a look at. The Signal Phantom YouTube channel. I'll have to have a look at that. And he says that Signal Phantom KA0KA is an amateur, helped me identify some radar signals a while ago that were US Navy, as they were in doing operations near China, which is an interesting one. So is it China over the horizon radar, or is it not? What else have we got here in the way of comments? One or two people fearing that World War III might be just around the corner. Well, it's good to be pushing 70. I wouldn't like to be a young person these days. Really, it's a world full of uncertainties, isn't it? We can only sort of maintain some degree of optimism and hope that wiser counsels will prevail. But with what's happened in America and elsewhere over the last few weeks, I really wonder. Okay, so it's round to Peter, VK3ACZ. And have you been doing any DX this week, Peter? VK3 Alpha Charlie Zulu and group VK3AML.
VK3GLC.
Acknowledging 3GLC. Back to you, Peter.
And good evening to Gary too there. VK3AML in the group, VK3ACZ. Good evening, Chris. Good evening, Dave and listeners. Been recovering from the plague this week, the great pestilence, and I certainly hope I'm sounding a lot better than I did at this time last week, because I was with you for a little while, Chris. Where do I start? Oh, first of all, just quickly, it's been an okay week. No DX at all, but I got myself out on a hill very close to home, a couple of minutes walk from home, to play a bit of VHF UHF field day today. And Ralph 3 Lima Lima with Damien's call sign 3KQ was up at Enfield, and that was 135 k's away, and he was booming in 20 over 9, and I thought that was as good as it was going to get, but I kept hearing a station in the background calling me, and it turned out to be VK3HJV Paul down in Portland. And to show that it wasn't a fluke, I had two contacts 2 hours apart, of course, as per the rules, with him, and exchanged good reports. So very, very pleased to think that on a non-tropo day, I was with the 5-element Yagi all portable and 6 watts. I forgot to add my Yaesu 818 radio with 6 watts was getting into Portland. Very happy with that. As good as around the world on the long path contact, if you ask me. But anyway, the SDR radio, the most significant invention since Sideband. Yeah, I can go along with that. That was a very impressive lecture that the fellow gave. But my interest has to be mainly with the over-the-horizon radar, of course. As a HF listener and worker, it certainly makes its presence felt. And I've got to say, Chris, there's nothing sacred, because the over-the-horizon radar will be heard over the marine the Australian Maritime Weather broadcast, which I would have thought were rather more important than ham radio frequencies. It doesn't surprise me at all that 15, 20 metres, 40, 80, you name it, we get bothered with woodpeckers and all sorts of squawking noises. I can confirm what Pirate said to you on the talkback. There's a radio site with quite a few of the different sounding over-the-horizon radars. The one that bothers me the most, I think, almost sounds like a square wave. It's got such a rapid thump to it. It can go for half an hour to an hour, and it will wipe out, say, the whole voice section at 20 metres. That's a real pain, that one. There are others that sound like a modest sort of a woodpecker that may last for 90 seconds and then off for 90 seconds and continue on, only occupying a small part, say 100 kilohertz or so. Would love to know what they are. I remember one day having to deal with a woodpecker, and a JA said to me, the Chinese have started broadcasting again. And a few minutes later I was talking to somebody in Europe who said, the Russians have started again, but they were referring to the same station, so I don't know, who knows where it comes from. The official version, or at least what I heard via the media about the official version with Malaysian Flight 370, was that Jawn was switched off at the time. Take that as you may. Whether it wasn't able to detect anything or it actually wasn't working, who knows. I'm sure they'd never come out and publicly say that we missed it, but I do recall a television or radio, no, it was an ABC report that said that Jawn had been turned off at that particular time. Don't think I've ever heard John, except for maybe on 15 metres it pops up with those funny tones that our one makes that's significantly different to all the others. But anyway, enough for the first round. Chris, you better get to and sweep your floor. It's looking a bit tatty there. Hi. No, it's good to get the second view of your shack. VK3AML in the group, VK3ACZ.
VK3ACZ in the group, VK3AML. Yeah, well, the second webcam came about through two things. First of all, apparently 3ADD, Mick Maxwell, had a project that he'd never proceeded with, which required an extra webcam. So he had this thing sitting in a drawer or something. He wrote to me, email, having heard my conversations on the Saturday sessions, and offered me the thing, and I certainly snapped that up because it just happens to be the same model as the one I already had, which made it very convenient to switch from that to the other. And the other thing was that we got a comment from, I'm just trying to think of his call sign, has a little dog, as many people do. I'm just trying to think of the name. It'll come to me. Craig, I think. Said to me, look, the last half of your Saturday transmissions, all we get is this single medium shot of you. Can't you vary it? And I thought to myself, only with a second webcam. So we go up to the switcher and we switch on to the webcam, and that's about the best I'll do for the moment. I've tried to clean the floor up, Peter. You wouldn't believe the number of papers I had to sort to get it to this stage, because tomorrow I'm bringing in the small rack to go to the right of me, where all of the, dog's breakfast of power supplies and transmitters currently are. I need to make them neater and put something of a patch panel in with them, and a couple of audio peak limiters to fix it all up. The SDR transceivers, yes, obviously Gerald Youngblood K5SDR, running the company Flex Radio, is pushing his product, but I do agree he got very much into the nitty-gritty as to exactly why the software-defined concept is, in basic physics, a lot better than the superhet, and will make radio transmission, particularly for non-voice modes, a hugely more greatly adaptable by hacking software rather than having to pull out IF transformers and change them over, or put in crystal filters, which I've never been terribly happy with. So with that, it's around to, and very impressive on the Wi-Fi operation of your station, Dave. You wonder how far this is going to go. We've got software-defined transceivers that we can put anywhere and operate from anywhere. So all those complaints about urban noise levels now can easily be solved by putting the bloody radio outside the urban, or outside the metro area. VK3GLC and group, and how are you, Gary? Nice to hear you there. VK3AML.
Yeah, VK3AML and group VK3GL. Yeah, just on come out here. It's not particularly cold, but just takes the edge off the shack and makes it in here one day. I've got so on that need doing, which I sort of haven't done. Can't say that I've done a lot of radio related, apart from around with computer software. I had a spare 5 minutes there. Still in the process of setting up the new shack PC. In my possession for at least 4 months. Taking that off of the old hard rubbish laptop that I've been using for the last couple of years, and transferring it over onto something of just a fraction more convenient. Finally got my third monitor working, which quite advantageous, although the positioning of the monitor's not good at the moment, but being an experimental concept probably doesn't matter too much. And now it's a case of and transferring software to the new PC and getting it all. Just didn't take too long, apart from the issue with a little piece of software called OmniRig that I used to control one or two devices here, and wasn't playing very nicely with the FTDX 3000, which was quite problematic. I was trying it with FT8. I know it's not real radio. We were playing. Yeah, every time it went into transmit mode, it shifted the mode of the radio to something that was not correct. Google is your friend, of course. Information came to light that there's some transceiver settings in a subfolder of the program that all I needed to do was put the right data in there and select the right option, and all was well. So I'm quite happy about that. So I can now use the X log for old man and all on 3 separate screens, and oh, it looks impressive. Don't know what I'll ever do with it, but it looks impressive. Can do. I did work a couple of those stations on FT8 the other day, late in the afternoon, quite by accident. One in Fiji and another one in Japan, which basically only lasted seconds, but it was. But yeah, other than that, not a great deal radio-wise. Well received, Chris. I was in the lounge on the. Your screen resolution is absolutely fantastic. I'm assuming you're in at least 1080p. I didn't check it. Well, that'll do for this round. See if I can remember something else on the next time round. VK3AML.
VK3GLC, VK3AML, and the carrier dropper. So we got about 2/3 of that, Gary. Notice hard rubbish laptop. I think a lot of people have been guilty of nicking those off nature strips from time to time. Quite often there's not very much wrong with them that a single new hard disk drive or something similar will fix. Very rarely that anything goes majorly wrong except for that and power supplies with electrolytics going off. And interesting about OmniRig, I should imagine that keeping up with all of the new rigs coming out would be very difficult for any piece of software to keep up with. Good on the FTDX 3000 as well. I'll just check my emails also. I know that people can get on to me by Hotmail, so I'll just check that source there. Opening Hotmail, that's always dicey. And what's in there? Anything at all? Can't see a great deal. And of course the fact that I'm Stuart has sent me a message. That's interesting. The QRM from the carrier dropper is reported as coming from the Geelong area. Interesting. Oh, well, I hope 3ZH is listening. And from the text chat, greetings from GLC X3ZGC. And who else is there? Remote ham radio access to flex 6,000 boxes around the US. It's an interesting idea. Yeah, well, the problem that we have in urban areas, Ardern, is in Australia as elsewhere, but perhaps particularly in Australia because we have so much cheap Chinese switch mode power supplies landing on our shores is the general white noise problem of the urban areas of Australia means that for HF receiving particularly, placing the transceiver outside the metro area is a major plus. And I know that a lot of retirees that I know that are in ham radio, if they have wives that are not particularly inclined to live in the city, mine is very much a city girl, so I'll never be moving out of the metro area, that people retire out to the bush specifically to play a bit more ham radio. Hello, Mr. Gary from the GOC. I presume, Gary, you'd know what that means. So it's back round to Dave, VK3ECG and group, and noting the drop data on the Wi-Fi. Is it possible your two Wi-Fi networks are actually on the same frequency and conflicting? It'll be interesting for you to give us a bit more of a rundown on that remote operation of your station. VK3ECG and group, VK3AML.
Yeah, VK3 ECG returning. Yep, absolutely, and good evening, Gary. Yes, you're very weak with me, Gary, but I was able to copy, apart from when the over-horizon radar noises hit you too, if you know what I mean. But yes, I mean, I worked it out. You could be right, Chris. I think actually I am running two different frequencies. The one's the 5 and the other 2, but or whatever. But so they shouldn't have been. But I think it was actually a bridging issue. Just a lot of delays. And as soon as I corrected the right network, it was fine. And the errors dropped to very, very low levels. So that was, yes, it seems quite fun actually. And there obviously you can do a direct connection. It's interesting. The software relies on, I think it's only Wi-Fi at the moment with the 705. I think if you've got a 7300 or some of the other ICOM rigs, it requires a direct Ethernet connection. But from my point of view, obviously there is a basis for having a direct Ethernet connection, using it as effectively as a computer, or using a Mac or whatever as your computer to run the rig. But from my point of view, it's that portable aspect of it, which means you can connect across, which is really very potentially interesting and so on. And at some stage I will, when one of the days I'm going to work, I'll take the iPad and leave the rig turned on at home and see what happens. But I think you're right. I mean, the noise levels are gradually rising, and of course with the spread of the urban areas, then there can only be a spread of the noise, and so you'll have to move further out to get away from it all. But yes, I've not tried OmniRig, and certainly there's some very nice software out nowadays for controlling radios, and there's quite a bit of free software as well. The FL stuff seems to be quite good, and I will have a play around with some of these things at some stage. Yes, finally, I mean, most of my shack computers have been actually really old computers, and even this one's pretty old that I'm using at the moment, although I pinched that from one of my daughters who said that hers was too slow to play certain games, and so I said, well, it's faster than the one I've got currently. So I'm using that now, which is interesting. Yeah, the MH370 was a fascinating scenario, and I did get involved with it a little bit, but on another front entirely, mostly related to, well, if they find it, what about recovery? But I mean, there's, I think, fairly good information from the the bits of plane that were discovered, washed up and things like that, although that doesn't tell you a great deal about the location, relying on marine currents and things like that to predict pathways. But over time, of course, things can move quite considerable distances, and we're well aware of that sort of thing. So it certainly was an interesting issue, and then there was a lot of discussion about whether general radio information would be issue. I think we discussed this previously. People were talking about whether the plane itself, as a reflector of radio signals and predictions on propagation, could have allowed it to be positioned. But I think whilst there was some theoretical possibility, it was completely impractical and was never going to work, and didn't work. And if the radar was turned off, well, it was turned off. Who knows? It certainly is a really interesting example of what can go wrong with loss of flights, and there have been some striking examples of not just machine failure, but obviously pilot deliberate failure. I think the plane that crashed in France, which was almost certainly a pilot suicide, and with killing the passengers, of course. Dreadful scenario, and an extremely difficult one to respond to, actually. But yeah, a particularly interesting issue, whether it will be found, or even if it is located, whether it will actually be recovered, I think is another question entirely. I think with the Air France off South America, they basically, even though they located it and they had started to do some recovery, they basically gave up, and not because it couldn't be done, but because it was unpalatable, and in fact the families didn't want it, which I think is really a very interesting scenario, and quite challenging. You're sounding good, Peter, I must say. Change the subject. Your voice seems to have got back to normal. I'm pretty good now, I think. I'll get a little bit tired, and I've still got a tiny bit of cough occasionally, but I don't think I'm really into the long COVID situation. But perhaps I haven't got quite the energy I had beforehand, but it's gradually getting better, and I seem to have got my top notes back for singing, which is a very good sign. So there we are. Anyway, back to you, Chris. VK3AML and the group VK3ECG.
VK3ECG and group VK3AML returning. Yeah, I'm glad you're back on top of things, and no doubt Peter will be eventually, and we'll be able to do those trips up One Tree Hill, Peter. Yeah, the gaming side of things, friends of mine who have teenage kids, generally younger than me, all the people that are my age, generally the kids have become adults, but the people who have teenage kids tell me that the computers that they have to have for gaming have to be considerably faster than most of the computers that we would ever need. Fast video address times and low latency and all the rest of it, and multiple core. So if you find a gaming computer on the nature strip, you've hit the jackpot. Interesting that you mentioned the MH370. It happened on a day that I'll never forget. It was my 60th birthday, 8th of March 2014, and it just happened to be the same day that we sold our previous house. We had the auction that day. And what a birthday gift that was. The house went for 2.5 times what we thought it would go for at Surrey Hills. When we bought into Surrey Hills in 1995, it was not a tremendously desirable suburb, but had become so as a result of Asian concentration in nearby Box Hill. And the fact that we were on top of a hill apparently made it very desirable. So we made the money that day. Probably more than we'll ever see again in one day. But all the time I was thinking of those people in MH370, thinking surely the thing will turn up somewhere, even if it's in the Himalayas or in Red China or whatever. Never did. It's I think one of the first times in my lifetime that a airliner of that size has literally disappeared off the face of the earth. So there must be some explanation to it. Whether somebody's hiding something, I doubt very much. when you look at where they came down, or purport to have come down in the southern Indian Ocean, it's an area where virtually nobody goes. Very, very few. I mean, the expeditions they have to Heard Island, which is at the southern end of the Indian Ocean, are very few and far between. The Australian Antarctic Research Division gave up on resupplying Heard Island as a base many decades ago and haven't ever restaffed it. So it's one of those places that's an Australian territory with very few Australians ever visiting it. What else have we got here? Oh yes, the parts of the MH370 that turned up, as I understand it, turned up on places like Mauritius and Reunion and those islands in the western Indian Ocean. But as you say, so long after the crash, who knows where they'd been in the interim, and it would take a major bit of exploration of the ocean currents and wind direction to work out where they'd come from or been. Okay, around to Peter again. I'm glad to hear that you're back from the grave, Peter. I fear getting the lurgy myself, because Prue at the moment, with her mobility problems, is unable to walk any great distance and relies on me for support and supplies. So I have to be a bit careful about the health. Not that somebody who eats a bag of potato chips every couple of days is terribly healthy, but anyway, could be worse. I could be a smoker, I could be a drinker, I'm neither. VK3ACZ and group VK3AML.
Yeah, VK3AML in the group, VK3ACZ. Yeah, same here, Chris. And Dave, I'm glad to hear that you're well and truly on the mend. And yeah, my energy levels only suffer when it's time to do a bit of housework. And I say to Sandra, I think I'll put off. I think I'll put off doing the floors and the and the bathrooms and all that till tomorrow. Hi. But anyway, if the truth be known, Chris. I had influenza back in 2005, and that took me about 6 months to recover from. This was a doddle compared to that. But your mileage, of course, will vary, as will everybody's. But it certainly was a very unpleasant few days, and I still suffer from the stuffed up head and the thumping headaches and the occasional little febrile spikes and all that, but certainly getting there. Don't know if I'm infectious, but the last thing I want to do is give it to anybody, so I'll be still self-isolating for a while to come. I'm just grateful that Sandra had nothing more than a mild cough. She really did it in a cakewalk, and whether that was the 4 vaccinations and not 3, who knows? I don't know. I'm uncomfortable with the whole vaccination thing, because to my mind, you don't get a flu shot so you'll get a lesser dose. You get a flu shot because you believe you're going to be protected from it, and so I would have thought it would be with COVID, but apparently not so. But anyway, enough of all that. Changing the subject a little bit, as well as having the 2 metre fun this afternoon with the UHF field day, I late last night heard my voice come back from the International Space Station. I sent my voice up there on 2 metres and it came back on 70, and whilst I didn't make a contact, it was good enough for me. I'd actually got there and back, and very happy I made the trip. I tried a few times when the repeater first started up, and I was getting killed in the rush, so I've left it till late at night, and it's usually when there's nobody there, wouldn't you know. But anyway, last night on Clint, that's 3CSJ, who operates as VK3EKH, the Astronomical Society Friday night broadcast on 80 metres, 3541, and on 160 metres last night it was 1865 AM. Sometimes he broadcasts sideband. I figured that we better give him a plug, because last night he gave this broadcast, this test transmission of yours a plug on his regular Friday night transmission. So I was pleased for Clint to do that. His show every Friday night at 10 p.m. is very informative and very good, like this one is. Back to Malaysian 370 just for a moment. Yeah, I think Madagascar was one of the places where a piece of a hull or fuselage or something suddenly turned up with the tide. I bemoan the fact that I suppose 9/11 really changed the landscape forever, but one of the things I always did, whether flying domestic or international, was always say a polite word or two to the flight attendants to see if I could have a look up the front, and I was never ever refused, and I was very gratefully accepted and received by the flight crew at the time. In fact, even allowing me to rejoin them for the landing at Tullamarine, which was with Ansett, so that'll never happen again either. But it used to be wonderful to be welcomed up the front and ask what I hoped were intelligent questions of the flight crew while we were there. I can see why it's not possible anymore, but I'm just saying that I'm sad that it's not. And especially in this situation, it hardly bears thinking about that. Well, at least we know for a fact that the Air France one was a pilot deciding to commit harikari and take a whole lot of people with him. Just a frightening concept, one that absolutely chills me to the core. But anyway, my last comment for this over, Chris, is that the over-the-horizon radar we were getting wasn't interfering with Gary's signal at all here, so it obviously isn't from this part of the eastern suburbs. VK3AML in the group, VK3ACZ.
VK3ACZ and group VK3AML returning. Yeah. Well, first of all, Clint, VK3CSJ, does a terrific job with that Astronomical Society transmission. It's kind of parallel to the thing I do here, except that Clint has gone that extra step and actually has an ATV transmitter and transmits it through the ATV repeater and on the BATC website. I've looked in a couple of times. And he does a very good job of that. Long-term interest in astronomy, which manifests itself in various ways, and he has that Sky at Night news of all the astronomical things that are going on, new comets or planets coming into a particularly good opposition for telescopic examination. So, yes, 3541 or 1865 kilohertz AM on a Friday night, 10 p.m. for Clint, VK3CSJ, and the Astronomical Society of Victoria's transmission, which he handles for anybody so interested. That business of going up into the cockpit, one of my grotesque favourite programs on TV is Air Crash Investigation, which I watch because I'm fascinated with the physics of all the things that can go wrong with an aircraft and how they've solved them, more to the point, which does kind of set your mind at ease that such things in most cases have been corrected, although pilot error is always difficult to correct, human error, humans being so disparate. But I guess as crashes have been caused by the distractions of people up the front in the cockpit, they have to stop that sort of a practice. But as you say, it's sad. The view straight ahead through a plane's front windows is totally different to what you get looking out the side through a passenger window. And I know that because in the old days, my first home away from the family home, just by an incredible chance, was Flinders Island in Bass Strait. And in the mid-70s, when I lived over there, you would go in a twin-engine plane, a Commander, I think it was called, which took 8 passengers, and frequently, if you were lucky, you could get a seat next to the pilot up the front. The cabin of the pilot and the passengers was not differentiated in that aircraft. It was so small, twin-engine. And it flew at about 4,000 to 6,000 feet, so you could actually see and make out cars and actually see people walking around on the ground and cows and sheep and such. And we flew out over the top of Wilson's Promontory, then over all the little fragments of islands that 40 years later I would visit with 3SL and 3ASC when we went to Deal Island. But yeah, that whole business of the nanny state sometimes being imposed for safety reasons. I suppose it's essential if people are going to be foolish with that privilege. But yes, we miss that from the old days, that business of being allowed into places where now you're not allowed. So we move on to Gary, VK3GLC. Now, Gary, you were up Emerald Way, I think, weren't you? So I'm hearing you sort of up the valley of the Dandenongs, up past Upper Ferntree Gully and through the gun site, as it were, that leads up to Belgrave. VK3GLC and group, VK3AML.
Yeah, thanks, Chris and group. No, I'm actually located at Rowville, not too far away from the Stud Park Shopping Centre. Not, but the house was available at the right price, price 20 years ago. So when I moved over from the VK5 area, so yeah, it's just one of those things. But I sort of made the best of it at the moment. I've got the dual bander that is attached to this radio up at about 5 or 6 metres with some reasonably low loss coax, so it's not as bad as it could be. But yeah, it was one of the projects to be done since I've rehashed all of the shack here and put everything into rack cabinets, and it's nowhere near organised, but the two burning projects at the moment I think are finishing off the building of the, so I can make switching more efficient, and also DC power supply distribution. But I've got to locate some materials in the shed that are extra to what I envisaged before I actually started on the project, but it will happen. Just make things a little bit tidier. Speaking of software-defined radios and stuff, I actually put my little SDR Play RSP1 into use the other day for something more useful than just sitting here listening to stuff. Had an issue with the weather station where the I didn't seem to think that the actual outside data was displaying correctly. I wasn't actually sure whether it was the transmitter or the receiving bit, and I've only just recently replaced the batteries, so I thought a decent reset would have sorted it all out. But I was able to use the receiver to locate the exact frequency of the transmitter, and then use a piece of software called RTL_433. Runs under Linux to actually decode the data coming from the weather station, and yes, it didn't look really good, but taking the batteries out and giving it the long reset and putting it all back together again, so fixed it. But yes, the receiver was used for good instead of evil for a change. Not that there's much evil goes on around here, but it's amazing with that particular device. There's that much software and that many plugins you can use to look at various bits and pieces. It's a bit mind-boggling. Yeah, they've also got to sort out the storage shed too, and relocate bits and pieces of a television transmitter that was a years ago, and perhaps even assemble it and get it working. It's in some form or another, but in between doing housework and other things that I should really be doing, the old ham radio takes a back seat, but never mind. VK3AML Group, VK3GLC.
Yeah, Gary, just as a matter of interest, do you have facilities for Skype for future reference?
Yes, I do have Skype facilities. I think I've got it loaded up on most of my my machines. It's quite a useful device. Don't use it that often, but it's yes, I do have those facilities. Go ahead.
Yeah, well, the carrier dropper appears to be aiming at, for some strange reason, at you. So perhaps if you're coming on next week or the week after, we could try piping you in via Skype rather than via radio. Would that be possible?
We could do that. I'll pre-warn you. Yeah, it's amazing the amount of people I've upset over the years. It doesn't surprise me.
Yeah, I tend to have the same problem, so my attitude to is step up, take a number from the counter, and I'll deal with each of you in turn. Look, ham radio has some very strange people involved with it, and occasionally you'll meet some really strange people. People with problems, people who who have some problem with their anger management, or in the case of radio clubs, I've frequently struck people who try to build a power structure and make it difficult for other people to enjoy the club in the way that they would, which was the reason that I moved from a radio club that I was involved with up to last year to Sherbrooke Club, which is smaller and has a more amenable group, including Peter 3ACZ, who invited me along to the initial meeting, and thank you very much for that step, Peter. I really appreciate it. But yeah, look, as I said, if you the people on the stream can see, this shack is now in the course of reconstruction. A second computer, a good one, has just been acquired on my right behind the screen with my call sign on it, and that will be routed through the modem in the next room to provide an extra channel for Skype. So your head will come up on this screen on my right, and I can patch the audio in on the mixer that's on my left, and people that are watching on the screen at the moment can see all of that. To whoever it was who asked if this is 1080p, yes, the clips that I'm transmitting are all standards converted to 1080p before I run them, although some of the clips are only available in 480 or 720. I try to avoid any clip lower than 480. They tend to look crappy. Ones at 240 and 320p are pretty awful. 480 almost acceptable, 720 acceptable but not ideal, and 1080 look just about spot on. These webcams that I'm using, the Logitech, I think it's C930E, are capable of 1080, but needless to say, for a medium price range webcam, something with decent optical lenses would look a bit better. And I have to pour the light on here. I've got 1, 2, 3, 4 lights on in different parts of the room to provide enough light for this camera to operate, or these cameras to operate, without giving that jerky effect. The effect on webcams when you don't give them enough light, I find, is that they tend to integrate frames and run at 12 frames per second rather than 25. So it looks all jerky, but I have to burn up something in the order of 60 watts worth of LED lighting to make this fully acceptable and noise-free picture. Could be worse. We could be back in the days with smear-o-matic Vidicon cameras, and God were they awful. I'll just take a standby. Is there anybody else who'd like to come in before I hand it back to Dave for the final time round? VK3AML, just standing by. Any other breakers?
VK3VJ, it's just trying to untangle the microphone cord, Chris.
Oh yeah. What, you're sort of standing at a very funny angle or bending down under a rack to be able to talk through a microphone cord that's tangled to the point of being 2 inches long?
No, I'm in bed. I've got the radios, as you know, by the side of the bed, and I've got two leads to charge up phones and tablets and everything, and I'm watching dickheads in boats. I thought there was enough dickheads on the road, Chris, as you've probably seen on YouTube, but it would appear that there's just an equally amount of dickheads in boats. Back to you.
Oh, look, there are whole YouTube channels devoted to idiots at work. I mean, idiots demolishing houses, and they knock out the final stump that brings down the house on top of them, or, they chop down a tree, and instead of tipping one way towards the open garden space, they tip the other way back to their houses. And I suppose our willingness, there's a word for people who laugh at things that are bad for the people concerned. I think it's a German word. It's not very nice. But anyway, glad that you're having a bit of fun with that. Nice to be able to talk through to the bed space. So it goes around to Dave again. VK3CG and group, VK3AML.
VK3 ECG turning. Yes, fine. Yes, well, I probably haven't got an awful lot more to say. I mean, I think the flight deck experience is fascinating. I mean, I remember as a teenager being organised on one flight to be able to go up on the flight deck. I think it was one of those small DCs that crossed the English Channel and took a car ferry, but it was a plane car ferry that I think as a sort of special treat my father organised on one occasion, and I spent most of the time in the cockpit. Actually, it was great, and was there for the landing and so on. And I have visited cockpit sort of since then in more modern planes, but to be honest, that's all stopped, of course, as you know. And in fact, I remember the era I got involved in one bit of work around plastic knives and forks versus metal knives and forks, and physical harm and things like that, with all of those issues around people, terrorist activities in relation to aircraft and things like that. Yes, I don't think we'll see the return of that easily these days, and things have changed, I suspect, in a way that's not going to resolve any of those sorts of issues. I've listened occasionally to the Astronomical Society and Chris's stuff. It's very interesting, actually, and particularly, I'm one of those sort of slightly weird things. I actually did the equivalent of sort of VCE astronomy when I was in the UK. I did an O-level in astronomy. It was more of a sort of after-school activity rather than anything else. But there was actually an O-level in astronomy, which I did. So it was sort of like a school certificate thing, and which was quite fun, and had to convert things into sidereal time, and there was always questions on various bits of the solar system, as well as the life cycle of stars and all that sort of stuff. So it was actually quite fascinating. I don't know whether they still run those things. I suspect they're still there. I think that's probably all I've got today, really. As I just last about the computer, yes, I mean, I suspect that the current graphics card in some of the computers is certainly worth more than my last three computers put together. I mean, the graphics cards can be well over between $2,000 and $3,000 Australian just for the graphics cards alone. And of course, you think that people have got sort of warehouses of these doing Bitcoin mining and things like that. It is quite extraordinary. But that's where the computing power goes to create those amazing 3D rendered environments and some of them are truly extraordinary. Anyway, on that note, I shall call it quits. I've got a bit more work on my helping my daughter with. I've just built some more IKEA stuff today, and I've got a bit of fitting and things to do tomorrow. So I shall be back down the Camberwell way doing some of that. So 73s, everyone. Great to catch up with everyone again, and hopefully hear you soon next week or so. Cheers then from VK3ECG.
Yeah, cheers, Dave, and thanks for coming on, as always. By the way, I was listening to Steve Langley last night, his transmission to Frank, whose call sign eludes me, Frank, who has the sight problem, and apparently he's working his way out of COVID problems with the kids. You can imagine both he and his wife are teachers, mixing with kids in different schools on a regular basis, and he has, with his wife, 5 kids, each one of which can keep on bringing home COVID or some sort of iteration of COVID from time to time. It must be very difficult for the family to, infect and reinfect. So Steve has kind of backed off from contacting us because of our advanced years and the fact that Prue is so reliant upon me for support at the moment. So round to Peter. I wonder when the next meeting of the club's going to be. It can't be too far off. We're towards the end of June now. Isn't that amazing how fast this year has gone? And incidentally, Dave, may be of interest to you. I've been holding this off for several weeks, but I'm going to do a major Saturday night on the restoration of audio, not just tape recordings or defective communications audio, but audio off very early discs going back to the first orchestral recordings of all in the first generation, the first decade of the 20th century, and show how modern virtual mixers, virtual equalizers, and digital processing can process the crap out of early recordings to make things audible that were not audible before. So that'll be next week, but that's taken quite a few weeks to assemble, actually, getting illustrations both audible and visible from various sources. Round to Peter, VK3ACZ, and perhaps we better make this a final. I need to get up early tomorrow morning to start rewiring all of that kerfuffle to my right where all the transmitters are, and get that sorted for next Saturday. So that should be, the facilities here should be that much better, and I want to integrate Skype or Zoom with these transmissions to allow people interstate, overseas, or even people who are suffering from intentional QRM on our transmissions to be able to leapfrog the whole problem, and perhaps even include a video component with a webcam. VK3ACZ and group VK3AML.
Yeah, VK3AML in the group, VK3ACZ, and good evening to Jeff. Hope you're listening, Jeff, because I have something to say to you in a moment. But before I forget, Chris, the next Sherbrooke Radio Club meeting is Monday week, 4th of July, and I'll give you a bit of a clue. If I forget, if I'm there with a black eye, it'll be because I forgot Sandra's birthday. I must not forget. I better put a string around my little finger or something to make sure I don't forget that one, or my life won't be worth living. Hi. Jeffrey, just quickly, I discovered this week a couple of AMBO frequencies for the regional areas. I was of the understanding that they were on UHF and that they went either digital or encrypted, but I'm picking up analog transmissions on 165 meg and 166. Don't know where they're coming from. 2 separate channels. Not sure. Some of the stuff is tied together and some isn't, but I'm virtually listening to the whole state. Wondering, Jeff, if you know anything about it, where it's coming from. It's some kind of link, obviously. It's not their main transmission. But you are the go-to man. You're the expert with all the sensitive receivers into all that sort of stuff. I figure that you might know. If Jeff's not listening, well, delete all reference, Chris. Just thank you again for, and I'll include Clint on this because, as I said, he gave you a plug last night on his broadcast, which was very, very good of him. You both do an amazing job of not providing even just entertainment, but factual learning stuff that we can enjoy, not because, as I said, it's entertainment value, but because we're actually learning something from it. One last thing, that guy writing on the glass, I went back to my childhood with that. I saw Rosemary Margan there. Am I saying something that rings a bell with you there? The Channel 9 News with Eric Pearce and yes, herself, where she used to write the little pictures for the weather on a piece of glass, which would have meant writing backwards. And I know there are other ways to do it now, but I wondered, was that fellow drawing pictures and or writing print backwards on the glass for us to look at? Would like to see the rest of that broadcast as well that you transmitted just before the callback started. But anyway, all good. Thank you again. Appreciate your contribution very, very much, Chris. Cannot speak highly enough, and so thank you. VK3AML, have a great week. Look forward to seeing you on the same time, same frequency and all that next week, and or on the following Monday. This is VK3ACZ. 7-3, everybody.
Yeah, okay, Peter. Thanks for the compliments. It struck me that guy writing on the glass, it would be very difficult to do in mirror writing, and he was doing it very fast. And then it hit me, actually, while I was editing that if you were shooting through the glass from the other side, you would, of course, be seeing the print back to front. But, of course, you can flip the video mirror format in video editing, and that's probably what they've done. They've shot it looking through the back of the glass. It would have been back to front, but they've probably flipped it in video editing to be right way round again. It's very clever. But what it means is that if he parts his hair on the left, we're seeing it parted on the right, because that's not the way he really looks. Interesting. Yeah. And you'll definitely see me on Monday week at that meeting, whether you have a black eye or not. I can't think of anything else to pass on, Peter, except I'm enthusiastic to do that test up on One Tree Hill when the weather and your own self are better able to do it. Transmitting digital slow scan from up there. I might ring up some friends in Ballarat and see if we can organise some VHFDX, if not HFDX, of digital slow scan. So it's round to Gary to more or less tie the ribbons. This is VK3AML. And thank you for coming in on this, Gary. Very much appreciated that. Weather station issue. Just looking down the list of things that I put down here. I note you're wiring things into cabinets. I wonder if you have as much trouble with wire looms as I do, working out what goes where and then wiring. It's a bit like knitting. Something that takes a long time but you don't think much about. VK3GLC, if you're still there, Gary. VK3AML.
VK3AML, VK3GLC. Wiring looms, yes, not sorted properly yet, which is one of the reasons for the antenna cable patch frame. See, I know how to do things professionally, but when it comes to doing things around here, it all sort of gets thrown together and ends up being somewhat messy, and that's what was irritating me before I rebuilt the whole station about 6 to 8 months ago. In actual fact, I had to pull everything off of the shelf that I had it on and try and unhook it all, put it all away in boxes and get it out of the road, and then even move the shelving out so that I could untangle that was behind it. I should know better, but never mind. It's coming together a bit better this time. It's all thrown early at the moment, but as I say, which is basically getting the placing of the equipment in the racks as to where I want them, and then I can cable them up properly and just sort of operating various things temporarily. Something Peter said sort of triggered something in my mind a minute or two ago. You mentioned cakewalk. Yeah, that's actually something I've been using over the past month or so. I've got a couple of transceivers plugged in via USB to this digital audio workstation software, and been playing around with the VST plugins to basically metric and graphic equalisation and noise gating and de-essing and all sorts of stuff, and it's very impressive the sort of thing you can do where you can take a really messy signal, say on 40 metres of an evening, and convert it into something that sounds like a straight FM conversation. It's a fairly steep learning curve, but yeah, very, very, very interesting. But I'll get into the video side of it shortly. Something different to do. Again, Chris, it's all well received here, and it's nice to see some education on the airwaves. The other brainless oops, probably upset another 1,000 amateurs out there already. Never mind, it's what we do. So hopefully I'll try and get up next weekend. We'll see what happens. Depends as to whether I actually get time to come out and do stuff, but we will see. But I hope you enjoy your week, and I hope everybody else enjoys their week also. So good night, and thank you very much. VK3AML, VK.
Yeah, VK3GLC, VK3AML. We had the carrier dropper again, specifically on you. I have no idea why it's on you. The others, in one case, are weaker. I'll give it one try. Would that carrier dropper care to make some comment? Any comment at all? No, he just wants to drop carriers. Oh well. Anyway, this is VK3AML, hoping I've not offended anybody with the coverage. It struck me as being a little bit skirting close to the wind, doing coverage of over-the-horizon radar in view of its security implications, but I was careful to avoid anything that looked like it might even be a security risk, and kept myself to published sources. Now I'll have a look at the text chat on the channel. Jared Quinn up in Sydney. ME switching surface is my preferred way to switch vision. Jared does quite a bit of work with video in Sydney, and it's good to see him there. Talking about a $90 Behringer MIDI controller, more suited to my needs. Yeah, the Behringer gear, the only problem I've had with Behringer gear, Gary, is that my main Behringer mixer works perfectly in almost every respect except one of the two stereo channels on the headphone monitoring has gone west. I have no idea why. The rest of it works perfectly. It's stereo in, stereo out, 8 channels, no problem, sig to noise is impeccable. It's just that one channel's out on the headphone monitoring, but this is mono transmission, so I don't have to worry too much. What about your talkback if it's done in full duplex? I transmit on 147.475 and RX on 439. Tried it, can do it. But my diplexer is not sufficiently good that the crud from 2 metres doesn't get back into 70 centimetres. So what I've been shopping for at Hamfest's VK3 Pirate, what I've been shopping for is cavity resonator. And if you put a cavity resonator tuned to the frequency you're transmitting on, it removes all of the sideband and spur crud that's inevitable from any transmitter, and makes it much more easily possible to work crossband duplex or indeed crossband in-band. We're saying you just need hotkeys for your scene switching. Yeah, the one problem with OBS software for transferring from one camera to another, I can actually illustrate it if people are watching there. If I go from one camera to another, it will freeze frame for about half a second before it goes to the other camera. I'll switch to the other camera. You'll see it froze frame there for a moment. Now we're on the second camera. Now I'll switch back, and it freezes frame before it picks up again. So it can switch. It can switch video cameras quite well, but it has that slight glitch when you make the actual switch. Looking down the list, what else to comment on? Your freelance gig is Vision Mixer Replay Operator. Okay, Jared, I've seen the photos on your Facebook page of doing all of that stuff, so you must get used to doing things on the hop with that sort of kit. What do you say? As for our carrier dropper, are you sure it's a carrier, not some local digital noise? No, it's definitely the same guy trying to be a nuisance, particularly with Gary 3GLC, and not with anybody else. But I've been meaning for months to get hold of some sort of way, either Zoom or Skype, to bring in listeners that I know are listening, particularly in Europe, England, to a slight extent in America, though at the moment in America it's only about 6 o'clock in the morning, and people are bleary-eyed and chatting on internet's the last thing they want to do. But my friend Clint in Salt Lake City, Clint, KA7OEI, with whom I've done a lot of optical communication tests, I've actually visited him. I have yet to convince him to visit us in Melbourne, but eventually I'll do that, because it looks like the exchange rate will favour him for the foreseeable future. To get him in on these transmissions, even if it's by replay, would be very good. And now I've got the second computer, it makes it that much more easy. So with that, I'll take a final listen. Anybody want to make a final comment? VK3 Alpha Michael Emma, standing by.
VK3VJS.
Yeah, go ahead, Jeff.
Okay, and to Peter, that is the country ambulance service. And if you scan 165 megs, you'll find several transmitter sites on mountains, buildings, all over Victoria. And they operate a trunking service system. So that is the country ambulance. The city ambulance is now encrypted, just like the bloody coppers, excuse my French, and you can't hear them. At least we can still hear the CFA and the Melbourne Fire Brigade on P25. It's not encrypted. So that's what it is, Peter. Put your scanner on search and you'll pick them all up eventually from all over Victoria. Now, Chris, I had an interesting day today. A phone call from Anthony and snapped me out of my lethargy, and I headed over to Dandenong North to a pre-garage sale. And I came back with the back of the truck full of various goodies. You know, this gentleman used to be on 160 metres. He's now in care. The house is up for auction next month, and it's up to Anthony to get rid of all the radio gear, which includes a garage and several sheds full of stuff. This chap used to service televisions in Dandenong. No names, no pack drill, Chris, but Anthony's going to have a garage sale and also a HRSA sale on site. So I don't know whether there's anything there that might be that you may be interested in. But I was lucky today. There was only one other chap there, and he was interested in the valve, so I had a clear run. And I think I got some great stuff. And it all goes to this gentleman in care. So that's about it. So I enjoyed the experimental transmissions tonight, Chris. Very good. And I'm still watching these DHs in boats. My God, I don't think they have any sort of licensing or test system in America, because it's here comes one chap, full bore, up the beach, and overturns on the beach. So it might knock some sense into them. Anyway, good morning all. Chris, Gary and Peter, and I'll catch up with you all later. VK3AML for VK3VJS.
Thanks, Jeff. Knew you were the go-to man. 7-3.
Cheers, mate.
Yeah, sorry I didn't bring you in, Jeff. I wasn't sure whether you wanted to become part of the group or what, but always a delight to hear from you there. That guy in Dandenong, was he a jazz fan? There was one particular guy I remember on the 160 metre group who was deeply into trad jazz. Is that him?
I don't know about trad jazz, but I know he is a muso, or was a muso.
Ah, I know who it is. And he had a digital AM rig, didn't he?
I don't know. I never saw the amateur gear, Chris. That's inside. I was mainly outside in the shed, in his shed and garage. But you know who it is, but I say no names, no pack drill. He's in care. So I'll probably go back and help Anthony for the HRSA thing and or the garage sale. I don't know yet, but there's a lot of stuff there, including a concrete mounted Nally tower.
Now that'd get Prue divorced from me, wouldn't it?
I think so, Chris. But there's lots of aluminium tubing and TV antennas and all sorts of things. I had a ball there today, Chris, because I had no competition. It was open go for me. I loved it.
I can imagine, but if it's the person I'm thinking of, his 160 metre transmitter was a WIN radio, a very early software-defined rig, so very nice.
Yeah, that's possibly inside, but I did get some nice homemade low-band tuners, Chris, and I've got some beautiful, I'm having a senior's moment. The coils, the adjustable coils with the roller, can't think of the name of them, Chris, and a lot of other stuff. Oh, and the word, Chris, I couldn't think of it, is Schadenfreude, made up of two words, Schaden, meaning damage, and Freude, of course, joy. Somebody who gets joy out of somebody else's misfortune, Schadenfreude. In my best German. Over to you, Chris.
Yeah, well, some of the best comedy is based on it, like Laurel and Hardy. Talk about two blokes perpetually in a hostile world. You know, homicidal widows and women who want to marry Oliver Hardy because they're axe-murderers and all that sort of stuff.
I believe my late grandfather, Ernest, he passed, I don't think he ever watched television. He passed a couple of years after, but when he used to see Laurel and Hardy at the flicks, he had to hastily evacuate and go to the restroom, so I'm told.
Yeah, Schadenfreude. Actually, somebody on the text chat picked that up. I just couldn't grab the word. It's not a word that you use every day. FTJS, definitely a couple of people have identified the source of the carrier dropping is Geelong now. Interesting. Where was it? Somebody on the... here we are, Ardern. Oh, Ardren, I should say, he calls himself. Identified the word as Schadenfreude some time back. But that's two of you who've got it. Yeah, that was what I was trying to think of. And that underlies a lot of the nastiness you hear on CB as well, on a sort of a lower psychological level. Roller inductor is what you're thinking of, Jeff, and they're rare as hen's teeth. Some are good, some are bad. Depends on how much oxide. Back to you, Jeff.
Yes, Roger, Chris, and I did hear you a conversation with Ralph the other day, and these are World War II jobs, very heavy, and it looks like they're only silver coated or plated. They could do with a bit of Ralph's maintenance, so we'll be in touch with Mr. Ralph at a future date, but these are real heavy duty ones. Definitely World War II vintage breaker.
Okay, very interested. If you ever want to flog one of those, I could always use them. We had a talk, Ralph and I can actually illustrate this at the moment on the video camera, about space winding a coil. And for a crystal set, actually, crystal sets are easy to build in a mediocre way, but very difficult to build if you want to get every drop of signal out of your antenna and into the headphones. And we were talking about wiring, getting a solenoid in a cylinder like that, and somebody claimed that if you bent it around into a toroid, that the Q, the quality of the coil, the ability to tune out other stations, would increase. But it turns out, no, it doesn't. Because as you turn the coil around into a circle, as I'm demonstrating in front of the webcam, the outer parts of the coil spread, which reduces the inductance without changing the resistance of the coil, and that means lower Q. So it turns out that the best Q you can get from a given amount of wire is a simple cylindrical solenoid, like that. And I'm just sort of demonstrating this with a copper slinky in front of the camera at the moment. But yeah, I'd be interested to hear what comes of all of that guff, Jeff, and thanks for coming in. Back to you for a final, I guess, Jeff. VK3VJS, unless anybody else wants to pick it up. VK3AML.
Couldn't hear anybody. Yes, okay, Chris. I wasn't watching. I'm still watching. I'm going to dream about this tonight for sure. It'll be completely and utterly a maritime dream tonight. It'll be a horror dream of bad boatmanship. I can see it now. I wish somebody invent something to be able to record your dreams. For exclusive playback by the dreamer, of course, nobody else, because some of them can be quite raunchy. But anyway, it's definitely I'm going to be dreaming things nautical tonight, Chris. And I've got coils and things that this chap's wound, obviously 160 metres. So next time you've got to go on a dash down to JCar, let me know, and we'll have it arranged all out outside. Well, I've got to get into it tomorrow because I just can't move in the truck. I bought some old magazines in tonight and a beautiful handheld microphone, etc., etc. And we've got the usual chicken band radios. I was surprised how many that he had. So we've got all of those. Oh, God. I don't know, when's it going to end, Chris? Never mind, all the best, and if anyone else is still listening, all the best as well. VK3AML and any group. I've got to turn this off, Chris. I'm going to have nightmares tonight. VK3VJS.
Boating disasters by dickheads. Would you classify that as a wet dream? Sorry, I couldn't resist that. But yeah, I've seen those programs and some of them are mighty funny. Isn't it wonderful that so many portable means of video recording are around today, that most of this, if it's recorded, gets onto YouTube and then becomes a fad across the world. Yeah, okay. Well, it now being 12:32, half past midnight, I suppose it's safe to play something a little bit out of the ordinary, and a friend of mine this week sent me a recording called Mr. Radio Man. And the story of this recording is more or less as follows. There was in New York in the late 30s and early 40s a trade in raunchy records. They were usually sold under the counter, not shown on display. They were sold under the counter to reprobate men, particularly in this case in the radio industry. Fairly mild by modern standards, but at the time were thought of as being terribly shocking. We're talking early wartime, about 1941 or 42. And a woman called Carol Chappell was the singer of these things. She was on what they used to call the burlesque circuit, which is an early form of, I guess you'd call it stripping these days. She was, by all accounts, a 6'1" redhead with a potty mouth who only ever sung suggestive songs. And we live in a country where, fortunately, although we're limited to 450 watts of sideband or 100 watts of AM or FM, so that our power is limited, as amateurs were actually allowed to transmit music as a test. It no longer is illegal. So, after 80 years, here is Carol Chappell talking about her Radio Man.
Where's that radio man? Whenever I turn on my radio, and with static it starts to squawk, there's a radio man comes to my house, but he doesn't come to talk. He fools around with my ARRL. He tests out all the wires, and how I jump up from the shock I get from his amplifier. But what am I to do when his filter starts to hum, when his battery is leaking, and his transformer's on the bump? What am I to do when his chassis is a wreck, when his coupler won't couple, and he can't even neck? What am I to do when his tube is getting weak, when he don't have any pickup, and he needs a new grid leak? What am I to do when I ask for an encore, when I've lost all my resistance and he can't plug in anymore? Now what am I to do when he's worn out his detector, when his coil has lost its voltage? He'll say I shouldn't have nectar. And what am I to do when his current's getting weaker, when my condenser starts to sizzle and nothing comes from his loudspeaker? What am I to do when he can't turn on his switch? Why, I won't pay the bill, 'cause I'm an awfully mean little gal.
Carol Chappell, 1941. And I think that record would still be sold under the counter. VK3AML is now closing, and I'll listen briefly before closing properly. VK3 Alpha Mike Lima, listening before closing. And it's taken away everybody's ability to comment. VK3 Alpha Mike Lima now closing. And for the people on the stream, thank you all very much for your presence as well. Ardrin saying, oh my. That record came to me from a collector in California, Matthias Antonio Bombal, a friend who does film reviews on local radio stations over there, involved with the film industry, and came across that in a pile of records that he bought, I believe at a jumble sale, and was nice enough to make a digital copy for me and send it via email. Oh dear, one wonders what else he has access to. Anyway, with that, I'll close the link on the live stream for this week, hoping we don't get any copyright hits, and hope to see people again at 11:30 UTC next Saturday. That is 9:30 p.m. Melbourne time here in Melbourne on 147.475 megs, or indeed we'll try and arrange Skype or Zoom in the next few weeks now that we have the second computer working properly. So this is VK3AML thanking you all for your interest, and